Soil erosion. What is soil erosion? The soil erosion is a detachment and subsequent removal of soil particles from terrain surface due to the action of physical forces such as rainfall, runoff, and wind. On this picture, you can see how the water erosion process works. So when the raindrop falls to the Earth's surface with a steep slope, the rain drops due to kinetic energy and gravity forces starts to detach soil particles and transport them to another place, which is called deposition of the detached particles. Soil is naturally removed by the action of water or wind, such as background geological soil erosion has been occurring for some of 450 million years. In general, background erosion removes soil at roughly the same rate as soil is formed. Accelerated soil erosion is the loss of soil at a much faster rate than it is formed. It's a far more recent problem. It is always a result of mankind's unwise actions, such as overgrazing or unsuitable cultivation practices. Scope. Globally, almost 84% of land loss results from soil erosion processes. The estimated mean rates of soil erosion across the world range between 12 and 50 tons per hectare per year. Wind erosion. Wind erosion is a natural process that moves soil from one location to another by wind power. It can cause significant economic and environmental damage. So we can see here on this image, so wind, strong mostly wind, interacts with the Earth's surface, which is mostly consists from sand or other large soil particles, and starts to move it to another place, causing in these areas wind erosion. So soil degradation types. So this is the global map of soil degradation types, and as you might see that in different regions of the world, certain type of soil degradation prevails among others. For instance, wind erosion mostly prevails in water erosion prevails in western of Europe, southwestern of Europe, as well as in this area, part of Russia, in Southeast Asia, in certain eastern part of Northern America, as well as this place, and in some tropical areas of Latin America and Africa. Wind erosion prevails in these areas. You can see this sub-Saharan Africa, this Mesopotamia region, Central Asia, Mongolia, etc. There are also the other types of soil degradation, such as chemical deterioration, physical deterioration, etc. So they prevail in other regions as well. Causes. Wind erosion can be caused by a light wind that rolls soil particles along the surface through to a strong wind that lifts a large volume of soil particles into the air to create dust storms. While wind erosion is most common in desert and coastal sand dunes and beaches, certain land conditions will cause wind erosion in agricultural areas. So it is wind that drives the erosion, but it's mainly the landscape and conditions of the land which leads to the most damaging wind erosion. Impacts. Wind erosion damages human health, as airborne dust can cause asthma and other health problems. Agricultural production, by stripping away the fertile top layers of the soil and organic matter. Wind-blown soil can bury or sandblast pastures, crops and fences, contaminate wool and deposit salt. The environment when dust chokes creeks and deposits unwanted nutrients and salt, threatening plants and animals and causing blue-green algal blooms. Property as built structures can be sandblasted by wind blown dust and buried in blown sand. Economic activity when dust storms disrupt commercial activities and transport and create the need for extra cleaning. Water erosion. What is water erosion? Water erosion is the removal of the top layer of land by water from irrigation, rainfall, snowmelt, runoff, and poor irrigation management. Ultimately, rainwater is most frequently to blame when it comes to this issue. The flowing water moves the soil organic and inorganic particles alongside the land surface, depositing them in the lower landscape. The result of this would be flooding in the long run. So this is a process how water erosion might occur. So there's a precipitation falling on the top altitude, and this is a steep slope of the area. And gravity, first this due to kinetic energy, raindrops detach soil particles on the surface, and due to gravity forces it pulls down soil particles with water to this area, causing soil erosion, especially in this place as well as in this place as well. So this is along this stream channel. Stream erosion occurs, gully erosion, sheet erosion, and splash erosion. Types of water erosion. There are several types of water erosion: sheet and rill erosion, scalding, gully erosion, tunnel erosion, stream and bank erosion, mass movement, etc. So sheet erosion occurs when the thin layer of topsoil is removed over a whole hillside paddock and may not be readily noticed, as on this image. Scalding can occur when wind and water erosion removes the topsoil and exposes saline or sodic soils. So scalding is a conjunction of both water and wind erosion, and it causes a salinization of topsoil. Gully erosion happens when runoff concentrates and flows strongly enough to detach and move soil particles. So gully erosion, as you might see on this image, is more severe type of soil water erosion. Tunnel erosion is the removal of subsoil when water penetrates through a soil crack or a hole where a root has decayed. The soil disperses and is carried away with the flow to leave a small tunnel. The major cause of stream bank erosion is the destruction of vegetation on river banks, generally by clearing, overgrazing, cultivation, vehicle traffic up and down banks of fire, and the removal of sand and gravel from the stream bed. Mass movement occurs on cleared slopes in coastal areas. Gravity moves earth, rock, and soil material downslope both slowly, millimeters per year, and suddenly. For instance, rock falls. So mass movement is the most severe type of water erosion and soil erosion as well, and it causes huge infrastructure problems, might cause damage to human life, and it also considered as natural disturbance. How people affect erosion. So there are multiple ways people might affect to erosion processes. For instance, this here you can see building of construction sites always causes erosion because people remove the topsoil, the most fertile topsoil, which prevents from both water and wind erosion processes by building construction sites. Traditional plowing, as you might see here, also it reduces soil fertility, damages soil biodiversity, which keeps the soil fertile and healthy, and keeps preventing from water erosion. deforestation and overgrazing as well, as you might see on this image. So plants, both trees and just plant vegetation, both trees, plants and grasses protect topsoil from wind and water erosion by just preventing the detachment by water and wind soil particles. But due to overgrazing and human activity, deforestation in these areas might occur severe types of erosion, especially on these steep slope areas. Soil erosion modeling. Models. There are a number of soil erosion models developed in recent decades. Mostly they are divided into empirical, conceptual, and physical, as you may see on this figure below. So conceptual models are also called semi-empirical, statistical models are empirical models, and physical models are also considered as deterministic. So on this table you can see dozens of models to estimate water erosion, which were developed during the last 4 or 5 decades. And these statistics show how many times a certain model was implemented and applied by researchers from all around the world. And on the first place you can see Russell model, which was applied more than 500 times, which equals to approximately 70%. Russell model, which is more simplistic type of Russell model, was applied more than 400 times globally, which is equals to 14%. Also there is a WEPP model, which is also popular, was applied approximately 200 times, and SWOT model also becoming more and more popular because it was developed recently, but the popularity of this model is growing. And so these models take most of the percentage, almost half of the percentage. Other models are applied not so much, not so frequently. So USL is an empirical model for annual estimate of soil erosion and was further modified as Mussel and Russell. It is a simple model for predicting soil erosion considering rainfall, soil erodibility, land cover, topography, and flow rate for Mussel data. Advantages and disadvantages of USL. USL USLE is not event-based and cannot quantify the events that are likely to result in large-scale erosion. The use of slope length factor in USL enables the prediction of soil loss due to overland flow, but it's mostly applied to agricultural land for gentle slope and angle not more than 25 degrees, and does not estimate gully or stream channel erosion caused by raindrops. SWOT, physical model for predicting the impact of land management practices on hydrology, sediment, and contaminant transport in large river basins over a long period with integration of drainage, topography, soil, land use, and rainfall information. Advantages and disadvantages of SWOT. SWOT has different applications such as climate change, land use change, evapotranspiration assessment, ground or soil water impact, snowmelt processes, etc. Also, storm event-based high and peak flows are not well simulated by the model. EPP, physical model for predicting spatial and temporal distribution of soil loss, sediment yield, sediment size, characteristics, runoff volume, and soil water balance. Advantages and disadvantages of these models are predictions of the locations of sediment deposition and detachment are very effective, but the large computational data requirement of the model limits its applicability. Erosion 3D, a process-based model for calculating runoff, channel routing, and transportation and deposition of sediment. Advantages and disadvantages. Its requirement for few data and its compatibility with GIS make it flexible in estimating erosion. Because the calculation is based on a regular grid, the disadvantage of this model is similar to what is WATEM and SEDAEM model. MCDA, multi-criteria decision analysis, is a qualitative assessment process. It is a probability-weighted approach that allows a linear combination of probability weights of several thematic maps. The weightages of individual themes and feature scores are fixed and added to the layers by considering its role in soil erosion. So we will use this model during this course to estimate soil erosion. So you should keep in mind that it's qualitative assessment, not quantitative as SWOT or Russell or USSEL. Advantages and disadvantages. It is an integrated assessment approach used for identifying a solution with respect to multiple complex problems. It can provide a rationale for making the best decision. The model uses scoring factors and assigns a weighted index to several variables affecting erosion risk according to their influence in erosion based on expert knowledge. Selection of variables in such approaches are not scientific enough and not only based on assumptions of experts. So this is the end of our theoretical part. Multi-criteria analysis tools. What is multi-criteria decision analysis? Multi-criteria decision making or multi-criteria decision analysis is a subdiscipline of operations research and that explicitly evaluates multiple conflicting criteria in decision making, both in daily life and in settings such as business, government, and medicine. Conflicting criteria are typical in evaluating options. Cost or price is usually one of the main criteria, and some measure of quality is typically another criterion, easily in conflict with the cost. In purchasing a car, cost, comfort, safety, and fuel economy may be some of the main criteria we consider. It is unusual that the cheapest car is the most comfortable and the safest one. In portfolio management, managers are interested in getting high returns while simultaneously reducing risks. However, the stocks that have the potential of bringing high returns typically carry high risk of losing money. In the service industry, customer satisfaction and the cost of providing service are fundamental conflicting criteria. Stanley Zines helped popularizing the acronym MCDA with his article MCDM, if not a Roman numeral, then what? Intended for an entrepreneurial audience. Definition of MCDA according to Cipher in 1999 stated multi-criteria analysis is a decision-making tool developed for complex multi-criteria problems that include quantitative or qualitative aspects of the problem in the decision-making process. MCDA is used to compare and rank alternatives taking into account and evaluating their respective consequences. Example. For instance, consider two friends want to decide how to travel to Paris for a weekend, either by car, night train, or plane. So they have three options and several criteria according to which they might choose the best option. For instance, criteria might include the speed, the price, the comfortability, and the availability. And both friends assign certain values for each criteria, and according to computations, the MCDA choose the best option for them according to which criteria they assign the most. For instance, if for both friends the price is the most important one, probably night train will be the best option. Meanwhile, if not the price but the speed or convenience is more important one, then the plane it will be more the best option from three. And each friends, both of them have assigned their own values for different criterias, and MCDA will find the average the best one. So popular MCDA techniques. So there are dozens of MCDA tools and techniques, but the most popular one are Analytical Hierarchy Process, which will be used in this course, also Analytical Network Process, Base Criterion Method, Base Worst Method, Simple Multi-Attribute Rating Technique, Multi-Attribute Global Inference of Quality, and Multi-Attribute Utility Theory. Analytical Hierarchy Process. What is HEP? The Analytical Hierarchy Process, HEP, is a structured technique for organizing and analyzing complex decisions based on mathematics and psychology. It represents an accurate approach to quantifying the weights of decision criteria when expert or experts' experiences are utilized to estimate the relative magnitudes of factors through pairwise comparisons. It was created by Professor of Mathematics Thomas L. Saati in 1970s. Each of the respondents compares the relative importance each pair of items using a specially designed questionnaire. Decision situations. Choice: the selection of one alternative from a given set of alternatives, usually where there are multiple decision criteria involved. Ranking: putting a set of alternatives in order from most to least desirable. Prioritization: determining the relative merit of members of a set of alternatives as opposed to selecting a single one or merely ranking them. Resource allocation: apportioning resources among a set of alternatives. Benchmarking: comparing the processes in one's own organization with those of other best-of-breed organizations. Quality management: dealing with the multi-dimensional aspects of quality and quality improvement. And conflict resolution: settling disputes between parties with apparently incompatible goals or positions. Examples: opening a startup or running a business, choosing university, faculty, or department for education, buying a car or real estate or other device, finding a job or choosing a CAO for the company, and solving natural disturbances. Steps to conduct HEP. At the first stage, the issue and goal of decision-making brought hierarchically into the scene of the related decision elements. Decision-making elements are decision indicators and decision choices. The group establishes a hierarchy. As you can see on the figure on the right, there are three levels. The first level is the goal, which experts or other people or a company establishes and endeavors to reach. The second level is choosing the criteria. Criteria might vary from 1, 2, or to hundreds and thousands. And level 3 are alternatives. This might also change. Alternative starts from 2 and above 2. It can be 5, 10, or 50, etc. Second step. In second step, and in order to conduct pair comparison, a questionnaire should be designed and distributed among the respondents to collect their opinion. The scale ranged from 1 to 9, where 1 implies that the two elements are the same or are equally important. For instance, on the table on the right you can see importance scale and definitions of the importance scale. For instance, 1 implies equally important preferred. For instance, if you expert choosing between apple and banana, if he assigns scale 1, it means that these both fruits are equally important for him. Scale importance varies from 1 to 9, when 9 is extremely important preferred, and other values are something between. On the other hand, number 9 implies that one element is extremely important than the other in a pairwise matrix. Third step. In the next step, in order to validate the results of HEP, the consistency ratio CR is calculated using the formula CR equals CI divided RI, in which the consistency index CI is in turn measured through the following formula on the left. The value of Ri is related to the dimension of the matrix and will be extracted from table on the left. It should be noted that consistency ratio lower than 0.10, it means 10%, verifies that the results of comparisons are acceptable. See, you can see here the relative index values and dimensions. For instance, for the first dimension, relative index equals to 0, as well as for the second one, while for the 10th dimension, relative equence, average relative equence appropriately should be equal to 1.48. These are the values of random consistency index, which is taken from Golden and Wang 1990. So this is the end of theoretical basis of HEP. So this video is supposed to reveal how explain how analytical hierarchy process works on a practical basis. So as was mentioned before, it was developed by Thomas L. Saati, and is considered as one of type of multi-criteria decision analysis tool. The input can be obtained from actual measurements such as price, weight, or from subjective opinions such as satisfaction feelings and preference. So HEP allows some small inconsistency in judgment because human being is not always consistent. The ratio scales are derived from the principal eigenvectors, and the consistency index is derived from the principal eigenvalue. Don't worry if you don't understand all of these terminologies above, because the purpose of this tutorial is to explain that in a very simple way. You just need to read and go through with me. So let's start with pairwise comparison. So what does it mean? Now let me explain what paired comparison is. It is always easier to explain by an example. Suppose we have two fruits, apple and banana. I would like to ask you which fruit you like better than the other and how much you like it in comparison with the other. Let us make a relative scale to measure how much you like the fruit on the left compared to the fruit on the right, banana. So for instance, you're choosing between two fruits, and the scale ranged from 1 to 9, if you remember from the lecture about HEP. So 1 is equal, so you equally favor both bananas and apples, and it is hard for you to choose between them. Meanwhile, 9 is extreme favor either to banana or to apple. If you like the apple better than the banana, you think a mark between number 1 and 9 on the left side, so on this side. While if you favor banana more than apple, then you mark on the right side. So for instance, I strongly favor banana to apple, then I give mark like this. So I prefer strongly banana comparing to apple. Now let us have 3 fruits. The pairwise comparison goes the following. So we have cherries, bananas, and apple, 3 fruits, and we have to find out which fruit we prefer the most comparing to the other 2. So in this case we will have 3 comparisons. If we have only 2 options, we have only 1 comparison. It's called pairwise comparison. If we have 3 options, in this case 3 fruits, we have 3 comparisons, 3 pairwise comparisons. So you may observe that the number of comparisons is a combination of the number of things to be compared. Since we have 3 objects, apple, banana, and cherry, we have 3 comparisons. Table below shows the number of comparisons. So we can see here, so if 1 option, we don't have to compare. If 2 options, we have 1 comparison, pairwise comparison. If 3, then 3 pairwise comparisons, as you may see here. 4, 6 pairwise comparisons, 7, 21 already to pairwise comparison. So you can derive a number of pairwise comparisons in according to options you have using this formula. So you can see here, for instance, we have 10 options, number of things, let us roughly speaking. In this case, a total number of comparisons will be 10 multiplied 9, it will be 90, and divided into 2, it will be 45. So 45 pairwise comparisons when we have 10 options. So you see that the number of pairwise comparisons grows exponentially with the number of things. The scaling is not necessarily 1 to 9, but for qualitative data such as preference, ranking, and subjective opinions, it is suggested to use scale 1 to 9. You can also use scales 1 to 5, for instance, famous Likert scale, but I suggest you to use 1 to 9 scale because it is more precise and concise compared to Likert scale. So in the next video, we'll find out how to make comparison matrix or reciprocal matrix. How to make reciprocal matrix or comparison matrix. By now you know how to make paired comparisons. In this section you will learn how to make a reciprocal matrix from pairwise comparisons. For example, I have 3 kinds of fruits to be compared, and I made subjective judgment on which fruit I like best, like the following. For instance, I prefer bananas to apples slightly. For instance, we can say here that 3 slightly favors. And meanwhile, I prefer apple to cherry, strongly favor apple to cherry, and I extremely strongly, because 7 is very strongly favor banana to cherries. So we can make a matrix from the 3 comparisons above. Because we have 3 comparisons, thus we have 3 by 3 matrix. So the diagonal elements of the matrix are always 1, and we only need to fill the upper triangular matrix. How to fill the upper triangular matrix is using the following rules. If the judgment value is on the left side of 1, we put the actual judgment value. If the judgment value is on the right side of 1, we put the reciprocal value. Comparing apple and banana, I slightly favor banana, thus we put 1/3. So see that these are 3 fruits, and I'm comparing with 3 fruits. So apple is always 1 because I cannot favor one apple to another apple. So equal as well as bananas. So see across the diagonal. We have 1 values. Meanwhile, comparing apple to banana, I slightly favor banana. So therefore, I put 1.1/3 here. And comparing apple to cherry, I prefer apple, strongly prefer apple to cherry. Therefore, I put 5 here. So bananas with cherries is 7. Because I prefer a banana, strongly prefer banana comparing to cherry, and cherry with cherry is 1. So I strongly like apples, thus we put actual judgment 5 on the first row, last column of the matrix. Comparing banana and cherry, banana is dominant. So yes, you can see thus we put actual judgments on the second row, last column of the matrix. Then based on the preference values above, we have a reciprocal matrix like this. So to fill the lower triangular matrix, we use the reciprocal values of the upper diagonal. If ig is the element of row I, column j of the matrix, then the lower diagonal is filled using the formula 1 divided to this. So you will understand here, thus now we have completed the comparison. So apple with apple 1, apple with banana 1/3 because I prefer bananas, apple with cherry is 5 to apple because I prefer apple to cherry. Apple with banana with apple is 3 because here this number is 1/3, banana with banana 1, and I prefer banana to cherry strongly. Cherry to apple is 1.5 because I prefer apple to cherry. So cherry have 1 according to this formula, 1/5 and 1/7 comparing to banana and 1. Notice that all the elements in the comparison matrix are positive or more than 0. So you should notice that all these values are more than 0. So when comparing, you should first fill the upper part of the upper right part of the matrix and divide these parts into the divide 1 into these values, and you will have the opposite values. So I think it's clear, and on the next section we will discuss about how you will use this matrix. Priority vectors, how to compute eigenvalue and eigenvector. Having a comparison matrix, now we would like to compute priority vector, which is the normalized eigenvector of the matrix. The method that I am going to explain in this section is only an approximation of eigenvector and eigenvalue of reciprocal matrix. This approximation is actually worked well for small matrix equal to or less than 3, and there is no guarantee that the rank will not reverse because of the approximation error. Nevertheless, it is easy to compute because all we need to do is to normalize each column of the matrix. At the end, I will show the error of approximation. So suppose we have 3x3 reciprocal matrix from paired comparisons, as we just compared 3 fruits with each other. We sum each column of the matrix to get. So we sum values of each column. So we use the same denominator. Here is 5. So multiply 5 to 1 and to 3 will be 5 plus 15 plus 1, it will be 21, denominator 5. The same value is here, so here we should choose the unique denominator for all 3 values. So both of our here values, the first and the third, have denominators 3 and 7, and the unique denominator will be 21 for them. And we will multiply 21, so we multiply 7 to 1 because we have to multiply 3 to 7 in order to get unique denominator 21. Here we multiply 1 to 21 because it doesn't have denominator, and here we multiply to 3. So 3 plus 21 will be 24, and 24 plus 7 will be 31. 31, denominator 21. Here we don't need the denominator, the value, some value will be 13. Then we divide each element of the matrix with the sum of its columns. We have normalized relative weight, the sum of each column is 1. So now we divide each value to the sum and we get reverse values. For instance, if we divide 1 into 21/5, we have 521, so the values change. Vice versa, an opposite way. So 3 divided into 21, 5 will be 1521, because we multiply 3 to denominator, and the eventual denominator will be 21. So I hope you're familiar with basic arithmetics and you know how to compute and to work and process with fractional values. The same here, so we divide all values to the sum of its column. Here we divide these values to the sum of its column, etc. So for instance, here will be, if we divide 5 to 13, will be 5 denominator 13. Here 7 denominator 13 and 1 denominator 13. So the normalized principal eigenvector can be obtained by averaging across the rows. So now we just summing the rows, the values for it. Now we're working with our rows, not columns, and we're summing the values for each row, the first, second, and third, and multiply each value into one slash denominator 3. So let us open our calculator, engineer calculator, and let us try to use one row as an example. So 5, so I just open the parentheses. So 5 divided into 21, I close the parentheses, plus I again open the parentheses, 7 divided into 31, I close the parentheses, plus I again open the parentheses, 5 divided into 13, I'll close the parentheses. Yes, this is and now I should divide it into 3, because I'm multiplying into one denominator 3, so I'm dividing it. So see 0.2828, so at the same value we have here. So using the same process, you can calculate the principal normalized eigenvector. This is eigenvector by summing the values for each column and eventually multiplying them into one denominator 3. So the normalized principal eigenvector is also called the priority vector. Since it is normalized, the sum of all elements in priority vector is 1. So if you will sum all the values of the priority vector, you can just sum it in calculator. 0.28 plus 0.64 plus 0.07. So it's using, if we'll use all the values, we will have 1 here. So the sum of the values of the priority vector is 1. The priority vector shows relative weights among the things that we compare. In our example above, apple is 28%. So this is apple. So the priority vector or eigenvalue for apple is 0.2828. So it equals to 28%. Banana is our second fruit, second row. So the priority vector or eigenvalue or the value in eigenvector for banana is 64, that means 64%, and for cherry 7.38%. So thus most preferable fruit is banana, followed by apple and cherry. So in our case, banana is more preferential, using this pairwise comparison. If we assign these values during the pairwise comparison, thus we prefer banana strongly on the first place, 64%, apples 28%, and cherries 7.38%. So in this case, we know more than their ranking. In fact, the relative weight is a ratio scale that we can divide among them. For example, we can say that you like banana 2.27 times comparing to apple, and as much as more than 8, almost 9 times comparing to the cherry. Aside from the relative weight, we can also check the consistency of your answer. To do that, we need that is called principal eigenvalue. Principal eigenvalue is obtained from the summation of products between each element of eigenvector and the sum of columns of the reciprocal matrix. So how we do this? So we have values of eigenvector, and we multiply to sum of columns. So we multiply apple eigenvector value from eigenvector to some column of apple. The same we do with bananas and cherries. So the same we do with bananas and cherries, and we have 3.0967. So this is our principal eigenvalue. Consistency index and consistency ratio, or what is the meaning of consistent? What is the meaning that your opinion is consistent? How do we measure the consistency of subjective judgment? At the end of the section, you will be able to answer those questions. So let us look again on the judgment that we discussed on the previous section. So is aforementioned judgment consistent or not? So we have three pairwise comparisons. So first we prefer banana to apple. Thus we say that banana has a greater value than apple. We write it as B more than A. Next we prefer apple to cherry. Apple has greater value than cherry. We write it A more than C. Since banana is more preferable than apple and apple more prefers than cherry, logically we hope that bananas are more preferable than cherry. This logic of preference is called transitive property. Your answers in the last comparison is transitive, that you like banana more than cherry. Then the judgment is consistent. On the contrary, if you prefer the cherry to banana, then the answer is inconsistent. Thus, consistency is closely related to the transitive property. So a comparison matrix A is said to be consistent if Aij multiplied Ajk is equal to Aik for all I, j, and k. However, we shall not force the consistency. For instance, bananas is more preferable than apples, has values 3 to 1, and apples compared to cherry has values 1 to 5. We shall not insist that banana compared to cherry must be value 15 to 1. This too much consistency is undesirable because we are dealing with human judgment. To be called consistent, the rank can be transitive, but the values of the judgment are not necessarily forced to multiplication formula. Professor Sati proved that for consistent reciprocal matrix, the largest eigenvalue is equal to the number of comparisons, or this eigenvalue is equals to number of comparisons n. Then he gave a measure of consistency called consistency index as deviation or degree of consistency using the following formula. So consistency eigenvalue minus number of options divided into number of options minus 1. So in our previous example, this eigenvalue is equals to principal eigenvalue equals to 0.0967, and we have in our case 3 comparisons or n3. Thus, according to the formula, consistency index is this principal eigenvalue minus number of comparisons or options divided into 2, and we have 0.0484. Knowing the consistency index, the next question is how do we use it? Again, Professor Sati proposed that we use this index by comparing it with the appropriate one. The appropriate consistency index is called random consistency index, or RI. He randomly generated reciprocal matrix using scale 1, so 1 denominator 9, 1 denominator 8, etc. until 9, similar to the idea of bootstrap, and gets random consistency index to see if it's about 10% or less. The average random consistency index of sample size 10 matrices is shown in the table below. So we have a number of options, 10, and you can see here random consistency index starts to rise with rising the number of options. So in the internet you can find random consistency index for more than 10 options. As far as I'm concerned, there it calculated more for 500, even 1,000 options. So then he proposed what is called consistency ratio, which is a comparison between consistency index and random consistency index, or in formula. So this is consistency index divided into random consistency index. If the value of consistency ratio is smaller or equal to 10%, then inconsistency is acceptable. If the consistency ratio is greater than 10%, we need to revise the subjective judgment. So let us find out our consistency ratio. For our previous example, we have consistency index is 0.048 using this formula, right? And we have here random consistency ratio index for three comparison for three options, 0.58. So we divide just these values and we get 8.3% is less than 10%. Thus the subjective evaluation about fruit preference is consistent. So far in HEP we are only dealing with paired comparisons of criteria or alternative, but not both. So in our course we will use only this paired comparisons in dealing in assigning values to layers, but to find out so areas prone to erosion. But if you're interested in HEP and you want to elaborate your knowledge, you can also get acquainted with the rest part of the tutorial, which explains how to compute in a full hierarchy. For instance, have factors and choices here, level 1, level 3, etc. So it's a little bit differently calculated. So for instance, you have several 3 or 4 options, for instance, and for instance you have in our case 3 fruits comparing to each other, and above that you're comparing, for instance, their price, their effect to health, or their weight, probably their damage to ecology. So several factors. In this case you will have a more complex hierarchy. But anyway, we don't need a complex hierarchy in our course, but if you want, you can read about the rest part of the tutorial. I will upload it to the course and get acquainted how to compute in a full hierarchy HEP. So before starting our work in ArcGIS, you should first try to understand what kind of data we will use, download, and prepare to delineate our study area in proclivity for soil erosion. So first, this is the data we will prepare, and it consists of satellite data, field data, and model data. So satellite data, we will use 2 types of satellites, Landsat 8 and Aster satellite. So this data we will download from the internet. So Landsat 8 is a multispectral image which contains information for multiple electromagnetic spectrums, and this information we will use to create our land use and land cover classification map. So it's in raster format. Also, we will download Aster satellite, which is also in raster format. So they're both Landsat and Aster in 30 meter pixel resolution. So this is a Aster satellite image is it's a monospectral. It contains only one band, and it gives us information about the surface of a terrain of a study area. So it just gives us information about the altitude of our study area, but we will derive 4 thematic layers from just one Aster satellite digital elevation model. So we will derive slope, topographic wetness index, curvature, and stream proximity only from Aster satellite. So this is the most important image we will use data. So these are both of them are satellite data, and we will make in general 5 thematic layers from this satellite. The third type of data is field data, which incorporates only one type. It's FAO global soil data, which is in vector format, which will also download from the internet, FAO database. So it's some modeled information, it's not modeled, sorry, it's vector information which contains the basic soil characteristics for different study areas globally, and we will derive the information concerning our study area. So this information we will use in order to create soil texture or soil type map, which we will also use during our analysis. And the third type of data is model data. It includes only one type of data. It's climate research unit precipitation in MCDA format. So this data is modeled by University of East Anglia for the entire world, and it shows the amount of precipitation, annual precipitation, which falls into a certain region in MCDA format for many years, and this information we will use in order to derive precipitation map. So these are all our 7 thematic layers which we will prepare in order to in order to delineate our areas which are prone to soil erosion. So also do not forget that in my course, throughout this course, I will use projected coordinate system, which in meters. The unit is meters instead of geography coordinate system, which is in degrees. Projected coordinate system is always more comfortable to use in order to estimate areas. And my zone is UTM 42N, Northern Hemisphere zone. And pixel resolution for all layers will be 30 meters. So this also these layers, soil texture and precipitation, despite that soil texture first of all, despite its vector, will be converted into raster eventually, and as well as MCDA format, we can open it in raster format and we will convert it into 30 meter pixel resolution. So we can overlay all our 7 layers with each other. So they all must have the same pixel resolution, the same data format, the same extent, and the same coordinate system. So in order to start project, run ArcMap and create new ArcMap document in MXD file, in MXD format extension, and name it MSDA, and save it in one of your folders where you will just save all the rest of your spatial data. So, and we need to create 7 data frames in order to work separately with each data frame, with each thematic layer. And we also need to create the final MCDA data frame in order to overlay all our layers. So how it's created? So far we have one data frame, layers, and we should rename it. Let's first name it NDVI. This is our first layer, and let's create another data frame. So go to insert and add here data frame. So it's adding again. Let's continue to add. So the next one will be slope. The next one will be for instance curvature. The next one will be topographic wetness index. Stream proximity. Soil texture. And the last one is precipitation. So we have all our layers, and we need to create the last data frame, and we name it, let's do HEP. HEP soil erosion model. So our ArcMap document is ready, and we ready to start to working with it. So let's start from NDVI in the following video. In order to just switch from one data frame to another, you should just to activate it. So it's highlighted, and we can activate this one and this one. So if you're going to represent spatial data in which is contained in the data frame, you should activate it. Otherwise, you cannot see it in a view window. Classification. What is classification? Classification is a transformation process of the remotely sensed pixel values into a number of classes or themes. In other words, it is a transformation of continuous data into the thematic information. If this transformation process is based on specific knowledge of the classes and on decision rules in the future space, it is called a supervised classification. If no classes are known, the process is called an unsupervised classification. Supervised classification. The supervised classification is controlled by the specific user's knowledge of the classes. The start of this process is called the training phase, and the result of it is kept in signatures. These results are used with parametric or non-parametric decision rules. A parametric decision rule is trained by the parametric signatures. These class signatures contain, among other things, the mean, vector, and covariance matrix of the pixels of the training area. When a parametric decision rule is used, every pixel is assigned to a class, since the parametric decision space is continuous. A non-parametric decision rule is not based on statistics. Therefore, it is dependent from the properties of the data. If a pixel is located within the boundary of a non-parametric signature, then this decision rule will assign the pixel to the signatures class. Basically, a non-parametric decision rule determines whether the pixel is located inside or outside a non-parametric signature boundary. Unsupervised classification. The unsupervised classification is based on specifying some parameters to detect clusters within similar characteristics in the future space. In this chapter, the objective is to analyze agricultural and land use areas by using spatial as well as spectral parameters. Example. These are the example of unclassified satellite image. Red areas are belong to near infrared electromagnetic spectrum. Therefore, because vegetation mostly reflects near infrared, so these areas are considered as vegetation, either agriculture, rangeland, or forests. So when we start to collect these training samples on using ArcGIS and collect them into training sample manager, we start to collect for each land cover class its own training samples and allow ArcGIS machine software to able to distinguish different classes we want to create. And eventually ArcGIS starts to compare these different spectral signature bands for each land cover class which we collected, and according to this data it creates a classification map. So here you can see there are several land cover classes are distinguished by the GIS expert. So it's residential, cropland, forest and pasture, so 4 classes. And also or commercial industrial land, so 5 classes in general. And they all have different spectral signatures for multiple bands. So this is a final classification map which contains 5 land cover classes. Using the image classification toolbar and training sample manager, it was determined that training samples were representative for the area and statistically separate. Therefore, a maximum likelihood classification was performed from the toolbar. The classified image was then cleaned to create the final land use map as shown below. Benefits of vegetation. So why we need vegetation in order to protect from soil erosion? Reduces runoff, it's the first feature of vegetation. The second is reduced flow velocity, also sediment filtration, energy absorption. It also reduces pollution. It retains soil and more vegetation, thus less erosion. Therefore, areas which are considered have very high density of vegetation biomass or healthy vegetation are less prone to erosion. Therefore, they more protect erosion and assigned less values when considered among factors that lead to soil erosion. So that's it. So in order to create NDVI map, we should download at first Landsat satellite images, which is a multispectral image. So at first go to earthexplorer.usgs.gov. So you should have your own account here. If you're not registered, please register first. And so you will have here search criteria. So there is a global map on a view window, and on the left side you can see the search criteria. So first go and find your study area. So let's see that this will be my study area, and we should create and shape a polygon in order to let know the system which area we want. So I want this area. And so as my coordinates, so I outlined my area, and I should also now here there's a date range, and choose the dates where your satellite was date range which you want. I prefer to choose the latest years because it is more relevant to us. So I am starting with, for instance, 15th of April until from 2017, it was 5 years ago, and until 2021, for instance, the 1st of July. And here in search months, I just choose April, May and June. Probably I should prolong it until 10th, for instance, of June. Why I'm choosing these months? Because the peak of vegetation period starts in April and ends until the it starts in the middle of April in spring in my study area, and ends approximately at the beginning of June because it's a very hot climate. Probably you have different vegetation area, so before just downloading satellite image, it is better for you to know more about the peak vegetation period for your study area, because NDVI is supposed to create map for study area, and it's more valid if it is used for the appropriate vegetation period. So for instance, if you will create NDVI map for winter, it will be totally different. When the biomass is very low, it will be totally different comparing to the late spring or the beginning of summer. So, and also go to cloud cover and reduce it to 10%, because cloud covers part of land surface, and this will create obstacles to the appropriate land cover classification. So, and then go to datasets, and we should choose here Landsat. Landsat 8.9. So this is level 2. I prefer because it's more it's processed. It has a geometric processing. So additional criteria, no, I don't need it, and go to results. So now it's searching. See that now we can see tiles for our study area according to our search criteria. So this is the appropriate path and row for my study area is 153 and 031, and this is the date for the 5th of June. It has some cloud cover, but it doesn't overlay mostly for my study area. It slightly has cloud cover for my study area. So probably I can find the better option. I can close show browse overlay, just click off. I think this one is okay also. 5th of May. See that it has has almost no cloud cover, and it satisfies my needs. What else? Probably this is for the beginning of April. You can see here that in April here my study area has way more glaciers and ice cover comparing to the beginning at the late of or the beginning of May. So NDVI map will be different in this case. So there is also other pages which is relevant also for my study area. I prefer to choose only paths 153, row 031. So this is slightly overlays my study area, but not fully. See, probably your study area will fall into 2 tiles. In this case, you should download both of them and use mosaic tool. So also this one is not bad. I think this also satisfies my goal. So I can download all of them. So in order to download, go to download options, go to product options, and here is my Landsat collection product bundle. So it's more than 1 GB. So I click OK, and it starts downloading. So when we downloaded Landsat images, it is time to add them. So add all bands. So here we have we need the first band, from first band to 7th band, and also 10th band. But probably you can dismiss this 10th band also because it's thermal infrared. We will not need it. So here here are my all bands. So I just use Control button and choose them all, and clicking by the right button of mouse, I can group them into one new group layer, and I will name it Landsat bands. So and now I need to merge them into one image, so stack layers and create one image. In order to do this, I go to here, this is search tool, and I should find composite bands. So this is a tool in data management toolset, composite bands, and it is used to merge all bands, layers of multi-spectral image such as Landsat into one. So I'm choosing one by one all bands, from the first band, second, third, fourth, fifth, sixth, seventh, tenth, and I should also choose the the output location, Landsat. So this is for May, 9th of May. So, and also the year is 2017. And also don't forget to write the extension .tif and click OK. So it's now creating one image from 8 bands. So it will take some time. So the process is completed now. So I can just turn off this group band, and when I turn off the group, all these layers are turned off from view window. So this is my merged image. See that by clicking to this color place, you can see that there are now 8 bands. You can go also to properties and symbology, and you can see here in RGB composite, you can click to this button and you can see now we have 8 colors, and so far it's not in true color. Red band is now, so the band 1 for Landsat image, Landsat 8, it's aerosol, coastal aerosol. So in order to check this, which bands represent which electromagnetic spectrum, you can go to what are the bands designations for the Landsat satellites in the USGS website. So we should find Landsat 8-9. So our satellite is 8. So the first band is coastal aerosol, so we don't need it. The second band is blue, so we can go to the second band here and assign. So you should click to the color side and assign for the blue color band 2, because it's actual legit color. The band 3 is green, so do the same step. Go click to color and assign the third band, and band 4 is red, so assign the fourth band. So see, now its visibility has changed. It's now more clear, so we can see that it's true color as you just watching with your own eyes from the space to the land surface. So, and the next step will be, so this is a large area and my study area is much smaller. Here see that I can just outline the color, so outline color to red, so it will be more clear. So see that I need only this area, and in order to do this I go to Arc Toolbox. So again go to data management tool, no, not data management tools, spatial analysis tools. Here is the extraction toolset, and here is the function that I need to extract by mask. So I choose my Landsat, this my multispectral stacked image, and for the input raster or future mask data, I choose my study area shapefile, and of course I need to put the output location, study area. You can also write the for year also as well. So 2017, it's not bad actually, it's only 4 or 5 years of difference from the current year, and during this period of time the land surface doesn't face or encounter significant changes. So I just clicked OK, and now my study area is ready. I can turn off this image below, and I can turn off the study area as well, shapefile, and this is my study area multispectral that I need in order to process, in order to create NDVI data. Again, I should change the color composite into true color, and this is it. And with the next video we will create NDVI map. So here we already composited bands for our Landsat image, and it is time to create a classification land cover classes for our study area. So we can work both with cutted your study area, but I do prefer to work with the whole Landsat image, because here we have more territory and more area to take samples for, and thus making classification more accurate. So we need to distinguish classes, and so I changed the band composite and assign it for the red band 5, which is a near infrared spectrum, because it's easy for me to distinguish in this case areas which have higher level of vegetation. And you can see that the water here has almost dark color, because water almost absorbs all the near infrared energy which comes from to its surface. So in order to start classification, we first go to this tab, this area menu panel, and choose this classification, image classification. You can see the windows appears here, and so we need at first to collect samples. So let's choose this polygon and start to collecting samples. So here's the training sample manager, and you can see here that when I just create a polygon on the surface of a certain land cover class, for instance here I'm collecting samples for water, we can see here that it creates new classes. More samples you will collect, the better, and the more accurate will be your classification. So let's choose also from other parts, so we can see that there is water here as well. The clean water has absolutely dark and color composite when it comes to near infrared, because it doesn't reflect any near infrared energy. Here we have slight different colors, because the water here is mixed either with sand, soil, or clay, and or silt, or have more higher level of algae. So here we collect 11 samples, and by using Ctrl Shift I'm choosing all of them, and using this button, merge training samples, and I will write here water. So the next class will be glaciers. So glaciers and waters have very close and similar signature, spectral signature, because, well, it is obvious because both glaciers and waters made from H2O, but it is important to be able to distinguish these classes because they differently affect to the soil erosion rate. When the land surface covered by a lake which doesn't disappear throughout the year. I'm not talking about river streams because they might disappear throughout the year and it depends on the season. But water, such as a lake we just saw before, doesn't disappear, and therefore it is impossible to occur a soil erosion because the soil, well, it's doesn't contain soil on the surface, but glaciers, when they start to melt, they might cause soil erosion because water, when glaciers melt, they turn into water, and glaciers exist on the high altitude areas, and when they start to melt, the gravity pulls down water and thus might causing some water erosion processes. And therefore, it is important to be able to distinguish these classes on the land surface, but it is hard to do because they have very close signatures. So I collected many samples for glaciers, and I'm again using Ctrl Shift, and I'm merging, and I'm writing glaciers. And now I will collect samples for the barren land. So we can see here, these are the barren land. Barren land has very low level of vegetation, or almost no level of vegetation. Therefore, it is very prone to erosion, especially when it is located in high slope areas. So the barren land which are located on steep slopes or high altitudes are the major land cover class which is prone to erosion rate. So it has this color. We can just again check with turning again to red, assigning true color composite, and see that the barren land has this brownish color type. So these are all barren lands. Barren land. And the next cover class will be urban areas. Urban areas are not very prone to erosion because well, they're covered by construction sites, but areas which are close to urban might be covered prone to erosion because when building construction sites, people just remove surface vegetation and thus creating less healthy soil. So these white areas are urban and they have a slightly different spectral signature, but urban area spectral signature somehow close to barren land. So I will just, there are very small areas in my region which can be considered as urban. Is also considered as urban. So I think that's enough. Well, probably all yes. I'm just I'm writing here urban, and the next class will be also this rocks. Rock is also the land cover class, which is very prone to erosion as well, but not mostly soil erosion, but to another type of erosion, because it's not covered with vegetation and it's very close to urban spectral signatures. So in order to be more accurate in classification, I should add here a base map in order to be able to validate. So I hope you have good high-speed internet. So I add this imagery. So it's adding so far. So I added this. I added this imagery, so it has more higher level of resolution, spatial resolution, and it is easier for me now to distinguish land cover classes. But the one problem is that you should be able to have a higher level of internet speed. So these areas are considered as rocks. So these areas again, these areas, if we will turn off the Landsat image, all these areas as well, these areas are also rocks. So again, these areas, try to collect samples from different locations, because it will amplify the accuracy of your classification. So this land cover class also close to barren land, and something between barren land and urban when it comes to spectral signature. So I'm merging into rocks. And the next cover class I want to find out is forests. So I again change it to near infrared. So the colors that are the most dark red are considered as forests. So we can just even zoom. So these are forests, the most dark green areas. Again, this one. Well, these areas as well can be considered as forest, or areas with a high level of vegetation, dense vegetation and healthy vegetation as well. well, these are close to rangelands. Remember that these images are taken in two different time periods, and therefore it is not always wise to compare them when it comes to vegetation, because vegetation changes from season to season. So this area is also close to forest, and this one as well. Can even check the values of in this case red band. See that it has very high red values, that in this case mostly these are trees, forests or woodlands have this very high near infrared reflectance. So I think this is, so far it's okay. Anyway, even if our classification is not correct, not very accurate and precise, there is always an opportunity to increase the accuracy just after using post classification process. So now I'm going to collect this range lengths, spectral signatures for range lengths. So it has more less dark colors. So these areas can be considered as rangelands or grasslands or meadows, or sometimes it can be agriculture on an early stage, or it can be also sometimes harvested agriculture. But these areas which I'm collecting the information, mostly natural areas. So it is better for you to know well the landscape of your study area before starting classification. It will always definitely will help you to create more accurate classification. So again, I'm just choosing and naming it rangeland. So my land count classes are ready. I can change the class. Not water, is better to choose a blue color. The colors for my classes: so barren land is dark brown, urban is red, rocks probably this color. You can choose your own colors, it doesn't matter. And it's always better to save your collection of shape files for your study area. Collection of training samples. Notes. Here is save training samples in a shapefile format. So I'm saved, and the next step is to you go here and choose imperative classification. So I'm clicking to this button and waiting. So the classification is over, and if you still have problems, inconsistencies with your classification, you can always, for instance, add new samples, for instance, in order to correct your classification, to make it more accurate. I think my classification is okay. I can even, for instance, use this swipe tool and just check. See that mostly it is classified well. I would say that it's approximately 70-75% of accuracy, which is quite good for the study area, and I'm very happy that it could distinguish glaciers and water, because these classes, as I just mentioned before, are merged together most often, but it has some problems with these urbans and clouds, because clouds here classified as urbans, but it doesn't overlay with my study area, so I will not correct it. But anyway, you can correct adding new samples here and merging it with the previous one. For instance, I can merge it, for instance, with water, right, or create a separate file, but anyway, separate class, sorry, but anyway, I can merge it with the existing classes. So my study area classification is ready, and the next step will be to cut it. So before extracting the study area, it is better to do some post classification correction. So see that certain areas are here just urban areas, or rocks are mixed with barren land, or vice versa. So we see here, we can see that this area is considered as rocks, meanwhile they are they belong to urban area, and I need to open my training sample. No, this one, I guess this was. So yes, this is my last file for training samples, and it is better to add some new files. For instance, these are all can be considered as barren land, I guess. Even these areas as well. So I just Ctrl Shift merge them and merge with the barren land class. So now it's merged. Rocks and barren lands have different, slightly different inclination towards erosion. Urban, but they have very close, similar classification signature. So these are considered as glaciers, but these areas are waters, but they these river streams are close to glaciers when it comes to erosion, because they all disappear and throughout the season, throughout the year, and therefore cause erosion processes. So they have the same importance level. So I will leave it this, same. Meanwhile, this lake doesn't disappear, therefore it has totally different effect to erosion. So probably I need to collect some more samples for urban area. So these are all urban areas, but you see that it's mixed with vegetation. Therefore it has slightly different spectral signature comparing to just true construction sites. So I collected more classes, and at first I will merge them, and later on I will merge with urban. So again I go to classification, interaction classification. So it's creating classification, and now I can compare again. Well, slightly better. I think that my classification slightly improved. You can go again to image analysis, choose this image, and use swipe tool in order to compare. So I go and remove this shapefiles. So I think it became better. So it's now slightly better class, but still some areas are which considered either are rocks and urban areas, or urban areas mixed with vegetation are still classified as glaciers, but they have almost the same close impact to erosion rate, same how to say weight when it comes to erosion. Therefore okay, I will leave it the same, and the next step will be to cut my study area. So this is my study area, and I go to Arc Toolbox, Spatial Analysis Tools, Extraction, and Extract by Mask. I will choose my so this is my last file, right? I can just delete it, this one. This is my last file, and input raster, and for input raster or future mass data I will choose my study area, study area classification, and don't forget to write the extension and choose OK. So now it's cutting my study area from the general image. So now it's ready, my land cover area is ready. So I think that it is not bad classification. I presume that the accuracy rate of this classification is 70-75%, which is quite good for this large area. So I can even check the attribute table. The classes remain the same, and we will use it during the weighted overlay. So of course, if you are familiar with ArcGIS Imagine, which is a powerful remote sensing software, it is better to make a classification there, but it's not within the scope of the extent of this course. But if you're familiar with ArcGIS Imagine, it's always more suited to create more accurate classification rather than ArcGIS. Slope. What is slope? In mathematics, the slope or gradient of a line is a number that describes both the direction and the steepness of the line, as you can see on the image. Slope is calculated by finding the ratio of the vertical change to the horizontal change, y, between any two distinct points on a line. So a slope is here on this image you can see horizontal and vertical change, and slope something ratio between them. What is slope? So for each cell, slope tool calculates the maximum rate of change in value from that cell to its neighbors. So here on this image you can see the center cell, and here these are the values for altitude, so digital elevation model. And when ArcGIS computes slope, it computes slope for each cell, and it compares it with neighboring cells. Basically, the maximum change in elevation over the distance between the cell and its 8 neighbors identifies the steepness downhill descent from the cell. Conceptually, the tool fits a plane to the z-values of a 3x3 cell neighborhood around the processing or center cell. The slope value of this plane is calculated using the average maximum technique. The direction the plane faces is the aspect for the processing cell. The lower the slope value, the flatter the terrain. The higher the slope value, the steeper the terrain. The output slope raster can be calculated in two types of units, degrees or percent rise. The percent rise can be better understood if you consider it as the rise divided by the run multiplied by 100. Consider triangle B below. So this is triangle B. When the angle is 45 degrees, the rise is equal to the run, and the percent rise is 100%. As the slope angle approached vertical 90 degrees, as in triangle C, so we can see here it's close to 90 degrees, because the ratio between x and y is significant. The percent rise being to approach to infinity. So degree of slope, here, this is the slope, and percent of slope is rise to run. So there are two types ways to create slope, either in degrees or in percents. If the center cell in the immediate neighborhood is no data, the output is also no data. If any neighborhood cells are no data, they are assigned the value of the center cell. Then the slope is computed. If any neighborhood cells are no data, they are assigned the value of the center cell. Then the slope is computed. When the input raster needs to be resampled, the bilinear technique will be used. As an example of when an input raster may be resampled is when the output coordinate system extent or cell size is different from that of the input. Digital elevation model and the slope. Slope can be calculated from a digital elevation model, which form an important part of many GIS datasets. Equally important are the parameters and techniques used to calculate terrain, slope, as well as other analysis performed with the digital elevation model. Steeper slopes are shaded red on the output slope raster. So as you can see here on this image, this is a digital elevation model. So these colors are low altitudes, and these areas are high altitude. And when we create slope for the study area, you can see here that areas with high altitudes have higher slope areas, meanwhile areas with low altitude have low slope areas. Application. So in GIS mapping, slope can be very important for a variety of reasons, including suitability analysis, predictive modeling, and predicting potential hazards. Analyzing the terrain slope of a given location plays an important part in fields such as hydrology, site planning, conservation, and infrastructure development. So it's used in multiple aspects. Mostly in hydrological and meteorological analysis. Also, it can be used in conservation practices, for instance, because slope very significantly influence the erosion rate, and also in infrastructure. Also, it plays a vital role. Application as well in suitability analysis or predictive modeling. By calculating the slope within a GIS, areas can be eliminated that aren't suitable that don't fit within the model. In predicting potential hazards, areas can be seen as dangerous due to the steepness of a slope. This is a very powerful and useful tool in GIS. Slope and water erosion. All natural slopes are subject to continuous erosion forces. When the slope has been recently formed as part of new development or is in its original nature state, some form of erosion protection may be required. So as you can see here on this image, the area has the highest slope, and therefore when the precipitation falls onto the top altitude, the gravity pulls down water to low altitude areas, and thus during this process water detached soil particles and move it to this area, which is called the deposition area. Thus it calls different types of erosion, either it's sheet erosion, splash erosion on areas close to the area where water or raindrops interact with the land surface. Also it's rill erosion, gully erosion, etc. So slope plays probably the biggest role when it comes to water erosion process. So this end. So when we before creating a slope, we should download digital elevation model. So in order to do this, go to earthdata.nasa.gov. So you should be and go to find data. So you must be registered. So you must have your own profile here. If you're not registered, please register. Do it first. So and the next step is to find the study area. So this is my study area, and I use this polygon in order to outline my study area. So I am starting to draw my study area. So my study area is outlined now, and the next step will be just to find the ASTER data. So ASTER is contained digital elevation model for each part of the world. So it found see that it found 5 tiles, 5 images to download, and it doesn't in our case years and months are not important, because the digital elevation model doesn't change for many years. So these 5 tiles I need to download. So I start to adding them using with this plus button. See, and this number of files which I need to download, 5 number of files. The ASTER satellite images are very small in size compared to Landsat images, but all when it comes to megabytes or kilobytes, but at the same time see they cover the smaller area, and we need more images which we eventually will need to mosaic. So use this download button, download data, and it leads you to this image, this window, and you should download this digital elevation model TIFF in TIFF format, and just choose your location to download and start downloading. So when you downloaded all images, it is time to add them to ArcGIS. So this is my 5 digital elevation model image, and my study area partially overlaps with it, and the next step will be to mosaic these images into one. So before creating a mosaic of this image, it is better to apply fill operation, because when you apply fill operation after you mosaic it, ArcGIS often just creates some errors or mistakes. So it is hard for ArcGIS to process with fill operation for mosaic data. So initially let's try to understand what fill operations do. So at first go to Spatial Analysis Tools, Hydrology, and find here fill operation. So see in explanation it is written: fill sinks the surface raster to remove small imperfections in the data. So let us see that these are the digital elevation model pixels. So this is my image, which contains pixels of altitudes. Each pixel contains information about the altitude of a surface. So if one pixel has a smaller value, the next surrounding has higher values, the next one, for instance, has even more smaller values, and the fourth one has higher values. So eventually we see that there is a growing trend of altitude, but these areas and these areas have some imperfections. So what do fill do? It just removes these areas, just cut some values from a pixel and make the digital elevation model more smooth. So it is uncomfortable to apply fill operation when you have 5 images just using this operation. So I prefer to model maker in this case. So let's drop all images, raster image, to this model maker, and then again drop fill operation. Just click and just holding the left mouse button, just drop it onto the model maker, and let's start to binding. So the we can left the zoom limit as optional. So you can save it in your folder, but I prefer to save it in a database. So far I prefer to leave the way the ArcGIS prefers to save it. I will save the mosaic eventually. So we have 3 images connected with DIM. So this is the first image, so it's collected with fill, and the last image collected with fill operation. So see, my outputs are ready, and the last one I need to mosaic them, so merge all 5 images into one. So in order to do this, I will go to data management tools and go to raster. This one is raster dataset, which I need, and the mosaic to new raster. So I just again drop, just hold the left mouse button and just drop it. So it's one's additional. So this mosaic, and I open the mosaic function, just clicking to it, and again I start to now merge this output files. So I do not need the initial raster dataset like this. I need a filled raster dataset, digital elevation model. Here I can choose the location, so mosaic dem fill. No, I just need to search for a folder, so it creates it finds a location, and I here give the name. Don't forget to write the extension .tif. Spatial reference for raster, I will leave it optional. Here I will change it to unsigned 6p, because digital elevation model of raster dem is unsigned 6p. Cell size I will leave the same. Number of bands is equals to 1, because raster image, satellite images are monospectral, not multispectral. So I think it's okay. Now it's connected. So this one is the output, and this one is mosaic. So it will do it in several steps. First it will create fill image from the raw digital elevation model, and eventually will merge them into one using mosaic tool. So I just validate entire model and then push this run button. So let's wait while it runs. So it processing each image, each operation one by one. I hope that you have good computer speed, because if you working with large data and more images, it might take some time. So far so good. So it finished all fill operations, and now it merged all these output files into one. That's when Model Maker is useful, because it really facilitates the work. If I would use only ArcGIS toolbox, it will take me more time. So it's completed now. I can close, and I need this mosaic dam fill. I can close this image. I don't need them, so I don't need so far the. So this is one image. And also it was used fill operation in order to smooth some errors in raw satellite images. But the values low, the highest value, the lowest value is not significantly different. So see that the lowest value is 300. These values, low values, are more than 300, but the lowest value is 301. And the highest value is 4,475 meters. Let's try to find the same. There is no so high values in this image, so it just creates slightly different, changes the values, initial values. You can do the opposite. For instance, first initially make a mosaic map and use only one fill operation. It looks easier, but remember that when you use the fill operation for the mosaic dataset, ArcGIS quite often shows some errors. So it is hard for ArcGIS to process mosaic data using fill operation, rather than just applying fill operation for each aster image, separate aster image, and then mosaic merging them into one. So keep this in mind. So now we're ready to calculate slope for our mosaic data. So go to Spatial Analysis Tools and go to Surface toolset, and here is the slope. So we choose mosaic, and the degree, we can choose output measurement in percent rise or in degree. I prefer degree. So a method optional can be planar or geodesic. What is the difference between planar and geodesic? Let's read. Planar, the calculation will be performed on a projected flat plane using 2D Cartesian coordinate system. This is the default method. And the geodetic calculation will be performed in a 3D Cartesian coordinate system by considering the shape of the Earth as an ellipsoid. So let's click OK, and let's wait. I prefer degrees rather than percent rise. So my slope is ready for my study area. So this is my slope areas. We can just look. So these areas, green color, are low slope areas. See, very small, and dark red areas are high slope areas. So these are mountain areas mostly. So these areas are the most prone to erosion. And the next step will be to just cut our study area from this mosaic data set and reclassify it. So first I go to extraction, extract by mask, and I use the slope, and for input raster or shapefile I used my study area. So I click OK, So my study area is scattered now. See, this is my we can change the color symbology to the opposite. Let's choose this one. Okay, these are low slope areas, these are high slope areas, but this is enough because it is a continuous raster dataset. See, it doesn't contain attribute table. In order to use it in the future for during the multi-criteria decision analysis tools, we need to convert it into a discrete dataset. So we need to convert its float numbers into certain classes. So again, we should find reclassify tools. This is in spatial analysis tools, reclassify, and let's start to create this choose this extract slope and go to classify. So we have 9 classes. Probably we need to reduce it until 7 and manual. So this will be the first class, very slope areas, small slope areas until 8 degrees, from 8 probably until 16 degrees. This will be the second class, from 16 to probably 24. From 24 to 30 degrees will be the next class. This will be 35 degrees, for instance. No, not 35, probably 40. This will be until 50 degrees and above 50 degrees. So these areas will be very prone to erosion. This area is slightly less, and these areas are less prone to erosion. So again, from 8 to 16 degrees, no, from 0 to 8 degrees, the first class. We can change it until, for instance, 10 degrees. I think it's okay. Next one is from 10, for instance, we can increase until 17, for instance, degrees. This can be 25 degrees, 32 degrees, 43 degrees, for instance, 51 degrees, etc. So these classes are probably more appropriate. So again, let's change to slope class study area.tif. Don't forget to write the extension. So no data is no data. Click OK. Now it's reclassifying. Now my discrete data is ready, and I can write here from, if you remember, from 0 to 10 degrees, right? From 10 to 18 degrees, from 18 to 25, from 25 to 32. Honestly, I forgot the values. Let's repeat the same steps. It's better actually go to classify and just improve until 7 classes, manual. So again, until 10 degrees, probably 17, okay, 25, 33, 42, 52, and above 52. So, and now let's again use the reclassify tool. So it automatically, oh no, it doesn't automatically create it. We need again to use manual. So now we can compare to this from 0 to 10, from 10 to 17, from 17 to 25, 25, 33, 42, 52, 2. So it is always better to first write in symbology tool, using symbology tools, the range of classes, and only afterwards use reclassify tool. So again, I use slope reclass in tif.tif. Okay, now I can close it, and it's better always to write all these classes into attribute table. So I go to this first, go with the right button, go and start editing. So no, first first stop editing, and first create the add field, name it classes, and choose here text. And now we can use start editing, because when you already started editing, you cannot add the field. First you should add field. So classes from 0 to 10 degrees, from 10 to 17 degrees, from 17 to 25 degrees, from 25 to 33 degrees, from 33 to 42 degrees, from 42 to 52 degrees, and the last one above 52, or we can write from 52 to 78 degrees, so the maximum point is 78. So now I can go to again editor, save editing and stop editing. So now I cannot edit, I cannot add information anymore or change it. And now I go to properties, classified, no, unique values, correct, and I choose this classes here. I can change the color ramp, for instance, from this one. I like it, green colors are low slope, red colors are high slope. Now see, it is better for me to distinguish and to understand which color represent which class and which degree here. So these are low areas, so 10 or 17 degrees. These are high steep slope areas which are most prone to erosion. So this is it for the slope. So these steps we should do in order to create slope. First, download image, astral satellite image from earthdata.gov, then use fill operation, then mosaic images if we have several astral satellite images, then use apply slope operation, then cut study area for our slope, because we will download a large area, and eventually reclassify this continuous slope area cut for our study area into discrete data. Curvature. What is a curvature? Curvature is a quantitative expression of a surface outline, and it can be dipped and curved, concave and convex, as you might see on this image. Dam and curvature. The curvature function displays the shape or curvature of the slope. A part of a surface can be concave or convex. You can tell that by looking at the curvature value. The curvature is calculated by computing the second derivative of the surface. So on these two pictures you can see digital elevation model on the left side and the curvature function surface on the right side, and curvature is derived from digital elevation model. And minus values and plus values as well as zero values indicates the certain surface of the curvature of a surface. Influence and applications. The output of the curvature function can be used to describe the physical characteristics of a drainage basin in an effort to understand erosion and runoff processes. The curvature value can be used to find soil erosion patterns as well as the distribution of water on land. The profile curvature affects the acceleration and deceleration of flow and therefore influences erosion and deposition. The planform curvature influences convergence and divergence of flow. So on this image you can see that each pixel value has a certain value which represents a certain level of altitude. So these pixels have low altitudes and low values. Meanwhile, these pixels have higher values, and these areas therefore have higher elevation. In this case, curvature in this case are convex, and water just pulled down by gravity from higher altitudes to low altitudes, and these areas are prone to erosion. Profile curvature. The profile curvature is parallel to the slope and indicates the direction of maximum slope. It affects the acceleration and deceleration of flow across the surface. A negative value indicates that the surface is upwardly convex at the cell and flow will be decelerated. So on this image you can see that if the curvature has minus values, the surface is convex upwardly, and in this case if water falls into this area, the speed of water is decelerated, and therefore such kind of curvature is less prone to soil water erosion. Meanwhile, a positive profile B indicates that the curvature is upwardly concave. So concave curvature and at the cell, and the flow will be accelerated. So if water precipitation falls to this area or even this area, the gravity force moves down water stream on a fast velocity, and this kind of curvature is very prone to severe type of erosion. A value of 0 indicates the surface is linear. So if value is 0 is linear, this kind of curvature is less prone to soil erosion compared to this, more prone to soil erosion, so comparing to minus values, but less prone to comparing to plus values. Planform curvature. The planform curvature, commonly called plan curvature, is perpendicular to the direction of the maximum slope. Planform curvature relates to the convergence and divergence of flow across the surface. A positive value A indicates the surface is laterally convex at the cell. A negative plan B indicates that the surface is literally concave at the cell. A value of 0 indicates the surface is linear. Standard curvature. The standard curvature combines both the profile and planform curvatures. The profile curvature affects the acceleration and deceleration of flow and therefore influences erosion and deposition. The plan curvature influences convergence and divergence of flow. Considering both plan and profile curvature together allows you to understand more accurately the flow across a surface. In the following diagram, the columns show the planform curves and the rows show the profile curve. The planform columns are positive, negative, and 0, going from left to right. The profile curves are negative, positive, and 0, going from top to bottom. Curvature in ArcGIS. The curvature tool is to calculate the second derivative value of the input surface on a cell-by-cell basis. For each cell, a fourth order polynomial of the formula is fit to a surface composed of a 3x3 window. As you can see on this image, it's a polynomial equation of a second derivative, but do not worry, ArcGIS computes it on its own. So the coefficients A, B, C, and so on are calculated from this surface. The relationships among the coefficients and the 9 values of elevation for every cell were numbered. The output of the curvature tool is the second derivative of the surface. For example, the inclination of slope is minus 2 multiplied d plus AE multiplied to 100. So there are two types of curvature functions. One is in 3D analysis tool in raster surface curvature, and the second one is in spatial analysis tool. And so this is the end. So before applying curvature, we need to reproject our mosaic digital elevation model because fill operation is applied only for projected coordinate system. Meanwhile, our coordinate system so far is in decimal degrees, therefore it is in a geographic, which it belongs to geographic coordinates reference system. We can even check, for instance, go to properties and source, and here is coordinate reference system with GS84 in degrees, so it's in geographic coordinate reference system. And we need to convert it into projected coordinate reference system into UTM format. But before this, we need to know in which UTM zone it falls to. So I go to add data, and you should find the disk where you just installed ArcGIS. So go to ArcGIS desktop, and here is reference systems. So program files, ArcGIS desktop, and reference systems folder. And here you will see UTM shapefile. So just add it. So I go upwards and see that it's in this zone. And in order to understand which zone is, I go to the properties. Again, I go to labels. I just turn on label features in this layer, and here in label field I choose zone. Let's increase it. So see, it's in UTM 42 zone. So now I know my zone, and I go to data management tools, projections and transformations, and here is a raster, and I choose project raster. So mosaic DEM field and output coordinate reference system. I go to choose this projected coordinate systems folder. Here is UTM, VGS84, and my study area is located on the northern hemisphere. So you should know in which hemisphere your study area is located, and it was 43, right? I forgot already. 42, sorry. 42. Okay. Now it's converting, changing the coordinate system of my mosaic dataset. So now it's reprojected, and so in order to check, first I go to properties, source, and I see here it's in the UTM zone 40N to 2N, and I should also save it. I go to export data. I choose 30 meters to 30 meters. Remember that our pixel resolution must be 30 meters. So now no data leaves the same. I go to my curvature, ArcGIS maps, and so this folder, and here I choose mosaic dam field projected raster. So now I click OK. Yes, so I don't need this anymore, this as well. And now I can go to properties, for instance. So we both have a dataset coordinate system and a data frame coordinate system. I also prefer to choose a data frame coordinate system. I go to layers and VGS. I choose this one because this one is so it automatically shows this data sets coordinate system, and you can see that its shape slightly changed. So my projected dam now is ready to create curvature. So now we're ready to create the curvature. So go to Spatial Analysis Tools, and here is Surface toolset, and this is a curvature we'll use. Also there is a 3D analysis curvature, just in raster surface. So this curvature as well, but anyway, I honestly don't know the exact difference between this and the other curvature, but I know that this curvature is appropriate for our study, and I used this type of curvature also for groundwater potential mapping, flood mapping, etc. So most of the time GIS specialists use this curvature. I didn't use the curvature which is located in 3D analysis tools, honestly. So I choose the dam, and I choose again the mosaic. So I don't need this profile plane curvature, so I put z factor 1. So my curvature is ready. See, it varies from minus to plus. So minus values represent concave curvature, convex curvature, and plus values represent concave curvature. So where the velocity of water falling into the surface accelerated by the curvature, the land surface. And also zero values, remember C curvature is a plane linear type of curvature. So I go to symbology, classify, so I need two classes. So see that two types of classes, two values, just again 0, two values, just to distinguish this minus and plus. So let's change. So these are minus, so I need 3 classes. Actually I can add 3. So I can just say that this is minus 0.00001, and this will be 0. So this will consider as a linear curvature. So it's not changing. Okay, so 3 classes. So these are these minus values are these are convex so they decelerate water velocity and therefore doesn't amplify soil erosion, so water erosion. These are linear, so they neither do not accelerate water stream flow nor decelerate, and these are only amplify soil erosion rate. So now I need to cut my study area. So this is my study area. Also, I reprojected it into UTM format. If your study area shapefile, I will share this shapefile as well. Anyway, if your study area shapefile in VGS or Geographic Coordinate Reference System, you should reproject it again using the same tool, so projections and transformation. But it's a shapefile, so you should use this function, not this, because it's not right. It's only appropriate for rasters. So anyway, now I can extract my study area from the mosaic curvature, and my study area shapefile. Okay, let's click OK, and now it's extracting. So and now I should change classification because I'm going to reclassify it. So I might leave the same values, for instance 5 classes, using the natural breaks classification, because natural breaks, combines different types of classification of data, so it's more complicated and more accurate type of classification of large data. So these areas, I think that negatively doesn't amplify soil erosion. Probably they even just protect from water erosion because they decelerate water velocity. Also this one as well, but this one neither decelerate nor accelerate, but these values will definitely accelerate soil erosion processes. Probably I can change manually slightly. For instance, I can say that this is until -5. Oh no, just sorry again. So okay, I will leave it. I will choose 0. I will choose, for instance, 15 and 10. So these values are close to 0, and we can say that it's linear. These areas are, so they're convex, and these areas are concave. So, and now we're ready to reclassify. So choose this extract value, so again manual, no, 5 classes, manual, and look to this area. So I minus it to -1, and this one is 0, and this one is 15, for instance, and this one above 15. So these values, and I can compare again, almost the same. Yes, the same. And I will choose, so reclass curvature.tif. So we're converting it from continuous raster to discrete raster, and I will add classes, text, and I should start to editing it. So from minus 42 and 2 until minus 3.5 and 6. Sorry, 3.5 and 6. And from minus 3.5 and 6 until minus 1.0 approximately, from minus 1.0 until 0, from 0 to 15, and from 15 to 15.7. So now it's ready. I can save my edits and stop my editing. So I can go to symbology, unique values, and choose these classes here, and now I can compare. So now it's more clear for me, these values. This color have small say decelerate, and this value is close to 0, they're almost linear, and these values have a positive they amplify just soil erosion rate. So this is it. Topographic wetness index. So what is topographic wetness index? The topographic wetness index is the most widely applied hydrologic topographic index, which describes the capacity of a cell to accumulate water. TVI integrates the water supply from upslope catchment area and downslope water drainage for each cell in a dam. The topographic wetness index therefore has three key components: total catchment area, flow width, and slope gradient. Topographic wetness index expresses the terrain-driven balance of the catchment, water supply, and local drainage. When calculating the topographic wetness index from the digital terrain model, all terrain sinks and flat pixels should be removed first. Then total catchment area, flow, width, and slope for each pixel must be calculated. Finally, these three components are integrated into the topographic wetness index according to the equation shown below in red. So this is the topographic wetness index. So it's a logarithm of total catchment area divided into flow width, and this is all. It's a fractional value which is with denominator of tangents of a slope. So this is one way to create topographic wetness index. So formula, it's ln logarithm in brackets specific catchment area divided into tangents of slopes in radians. So this is a scheme of topographic wetness index. So a flow accumulation area, so C, it's a flow accumulation area, and B, flow direction and the corresponding flow width for a dam cell. So it's a flow width for a dam cell, and C, the tangents of the slope angle. So this is the tangents of the slope angle. So again, that flow accumulation area, and this is flow direction and corresponding, and tangents of a slope. Classification: areas susceptible for water accumulation and categorized by low slope angle will be represented by high topographic wetness values. At that time, well-drained dry areas associated with the low topographic wetness index values. The topographic wetness index is unitless. Application: Topographic wetness index is primarily used to quantify topographic controls on hydrological processes. So this index can also be used to characterize biological processes, including forest site quality, vegetation patterns, and annual net primary production. So these are steps in order to create topographic wetness index in ArcGIS. So first we already create that field for digital elevation model. Then we will create flow direction, and from flow direction we will create flow accumulation. Then we already created a slope in degrees, but then we should convert it into radians using this formula. Then calculate tangents of a slope with raster calculator, so with this. And then rescale flow accumulation. So using this formula, flow accumulation plus 1 multiplied cell size. And the last one is this formula, so flow accumulation divided into tangents of a slope. So first we need to create flow accumulation map. So initially you should again download all your raw raster satellite images. In order to create flow accumulation, first we should create flow direction first for each tile, and then from flow direction again for each tile we should create flow accumulation and then mosaic them. We cannot use mosaicked digital elevation model to create flow accumulation and flow direction because ArcGIS often have problems with mosaic data when it comes to digital elevation model and hydrologic analysis. So therefore we should repeat the same steps. If you saved digital field data for raw digital elevation model, then it's good. If not, in this case again we will open model builder and we will drop all these satellite images, and then again use this hydrology field tool for each image, and then we will use flow direction for each image, output image. So at first let's connect the input. So for 69 so again $70 $71 4270 again. Now it's 4270 and 4271. So let's delete this one and again drop the first. So it's 6941. Cannot find it. Oh, here it is, 6941. Now it's connected, and now we will connect this function. So field diff61, so flow direction is D8, flow direction type again field 7 D8, so output is the same, flow time D8. We're collecting all the D9 outputs of field and saving it. So flow directions now is ended, and the next step is to create flow accumulation again for each flow direction. So we will use these outputs. So flow direction field 1, flow direction field 2, flow direction field 3, flow direction field 4, flow direction field 4, connecting flow direction field 5. So now it's created, and the last step will be to mosaic them. So again, raster dataset, mosaic to new raster. So flow accumulation 3, 4, 5, 6, 7. So flow accumulations are ready. Output location I will choose. You should create your own, save it into your own folder. So I will choose this raster. So I will create mosaic flow accumulation.tif. So here I should choose unsigned 16-bit. So I will not change the cell size so far. So number of bands 1, small spectral. So again, going back to flow accumulation, so don't forget output data type float, and flow direction type which we used is D8. So again, going back, so 5 for 5 of my images will saved with this, and unsigned 16-bit, no, actually not unsigned 16-bit, 32-bit float, because it will be float number. So again, okay, flow accumulation have float values. Run, validate and run. So it's running, as you may see. So I hope that your computer has a fast speed if you're going to work with large amount of data. So now it's starting to create mosaics. So it took approximately 20-25 minutes for my computer to process all flow direction and flow accumulation for 5 digital elevation models, but mosaic was finished fast. So you can save, by the way, the model. For instance, you can save it in one of your folders. So you should create a toolbox just by clicking here and save it. within a toolbox. So now we can add mosaic flow accumulation. Let's see. So this is how its values can be seen. So we can see that flow accumulation creates some don't be scared by these values. Flow accumulation creates certain areas which accrue water coming from the top altitude, and thus creating river streams. So this is our flow accumulation. So remember, we have our slope for our steady area. Initially we created this slope of our mosaic, and then we have a slope for our steady area, but it's in degrees. We need to convert it into radians, and in order to do this we will go to map algebra raster calculator. So slope study area, we should divide it into 157, multiply to 157, and then divide it into 90. So output is slope radians .tif. So it's converting into radians. So now it's converted, but so far it's in projected coordinate or geographic coordinate reference system, but we need to convert it into projected coordinate reference system. As you might remember, UTM, my zone is UTM VGS UTM 42N. So I need just to go to the layer, click right button of the mouse, go to data, export data, and I just change from the raster dataset into data frame spatial reference. So it now takes the spatial reference system of a data frame, which I set to UTM 42, and also I need to convert this spatial resolution into 30 meters. So I again choose the slope radians UTM.tif and click OK. So see that these areas have low radians, these areas have high radians, and that's it. We created slope in radians for our study area in UTM projected coordinate reference system. So the next step is to create tangents of a slope. So again, I will use raster calculator. So I will choose slope in radians in UTM. So initially I need to choose so this function conditional. I can delete this one, and I will click here and put slope in radians, and slope in radians tangents. If slope in radians more than 0, then again I should find here tangents. This is tangents of slope in radians. Otherwise I will assign to values equal to 0 or equal to 0, value 0.001. So again, I should choose the tangents of slope that TIF. Okay, now it's creating tangents of slope. So these are the values of my study area or tangents of a slope. So again, 30 to 30 projected coordinate reference system. So some pixels equal to 0. For instance, these areas, they have no slope. So ArcGIS automatically assigned 0.001 according to the conditions which I set in raster calculator. Other areas which have high slope degrees and slope radians as well have high tangents of a slope. So see the last step before creating a topographic wetness index, we should rescale flow accumulation again using raster calculator. Initially, let convert. So this flow accumulation so far it's in project geographic coordinate system with these cell size values, and again we need to convert them into projected coordinate reference system. So to this one. So again, I'm just exporting data using this data frame and cell size 30. It is easier to calculate flow accumulation rescaled in 30 to 30 interpixel resolution. So I just name it flow accumulation mosaic 30 meters .tif. Sorry, this I need just to choose a location FA mosaic UTM, let's say. So it's ready, and now we are able to create FA scale. So I choose FA plus 1 multiplied 30. So FA rescaled. Okay, now it's computing. It's ready, and also we need to now this scaled, and I choose my UTM study area. So FA rescaled study area .tif. So this is my FRA scaled in 30 to 30 meter pixel resolution for my study area. So the last step is to calculate topographic wetness index. In order to do this, we open again our raster calculator, and we should find ln function. So this is ln, and we just divide FR rescale for our study area for tangent slope again for our study area. In order, if you forgot, these are our tangent slope and FR. So let's save it. So topographic wetness index .tif. So this is our topographic wetness index for our study area. So it is unitless, and in our case it varies from 1.95 to 1.25. So let me just zoom to this topographic wetness index. So see, looks very attractive. These pixels show have a high topographic wetness index because they accumulate water and soil that comes from higher altitudes to low altitude areas. So these areas mostly, these white areas mostly create some river streams when if the area have a high level of precipitation. So if this kind of land surface will be full of water, anyway it would accrue to in these areas and thus creating river streams. So these are low altitude areas and they have high topographic wetness index, and they just not accrue only precipitation, I mean water, but also they accrue soil that comes from high altitude areas. So these areas are the areas of deposition of soil, and therefore these areas are less prone to soil erosion because these places where soil just deposits coming from the top. Meanwhile, areas which have a low topographic wetness index are more prone to water erosion. So and the last step is to reclassify our topographic wetness index. So just convert it into anyway. First, let me just go to properties and go to classify. Well, I think these 5 classes are okay. These are low. I mean high erosion, proneness to erosion, proclivity. So these are also high. This is very high, high, medium, low, very low. So, and let me reclassify now, and topographic wetness index, class, 5 classes, natural breaks, manual, sorry. So it's, so yes, so this is the next one, second value, third value, also close to this, from 8.9 to 12. Yes, so when we just created natural breaks, it automatically created this kind of classification that we have. So okay, and topographic wetness index, reclass TIFF. Okay. So, and we should create new field, name it classes, in order to record our classes. So it's from 1.95 till 5.13. 5.13 till 6.71, 8.9 till 12.6, and from sorry, I think I missed with one class. So this is the first class, this is the second class, this is the I missed the third class. 6.71 until 8.96. almost all. Let's say just 9. Oh no, 8.96. So from 8.96 until 12.6, and from 12.6 until 25.7. so this is the highest value. 7.6. Okay, let's try 7.6. So editor, save edits, stop editing, and go to properties. So my data topographic wetness index is ready, so I reclassified it and saved it. Stream proximity. Channel. Stream erosion. Channel erosion is a natural process that benefits stream and riparian ecosystems. Erosion in naturally stable streams, such as streams that are in equilibrium condition, is evenly distributed and therefore minimized along the stream channel. Erosion is also a dynamic process where the movement, sorting, and distribution of sediment and organic material create a diversity of habitats. When streams are in disequilibrium, excessive erosion occurs in some channel locations, while excessive deposition occurs at other locations up and down the length of the streams. Some habitats become scored of beneficial woody debris and sediment, while others may become smoothed. Where stream disequilibrium is prevalent in a watershed nutrients, for instance phosphorus, that are attached to eroded sediments and released in unnaturally large amounts. Streams are one of the most effective surface agents and erode rock and sediment. Erosional landscapes such as the Grand Canyon have been formed by constant erosion from running water over millions of years. In addition to eroding the bedrock and previously deposited sediments along its route, a stream constantly abrades and weathers the individual rock and soil particles carried by its water. Hydraulic action, abrasion, and solution are the three main ways that streams erode the Earth's surface. So we can see here on the two images on the right types of stream erosion. So it depends on the width of a stream. So on the top picture, the width of the stream is lower, but the depth is more deeper, larger. Meanwhile, on the bottom picture, the width of a river, stream is very high. Therefore, the area of erosion, the area which is prone to water erosion, is larger, but the deepness of stream is not very high comparing to its width. Hydraulic action. The ability of flowing water to dislodge and transport rock particles or sediment is called hydraulic action. In general, the greater the velocity of the water and the steeper the grade, the greater the hydraulic action capabilities of the stream. Hydraulic action is also enhanced by a raw and irregular stream bottom, which offers edge that can be grabbed by the current and that create uplifting eddies. Abrasion. Abrasion is the process by which a stream's irregular bed is smoothed by the constant friction and scoring impact of rocks fragments, gravel, and sediment carried in the water. The individual particles of sediments also collide as they are transported, breaking them into smaller particles. Generally, the more sediment that a stream carries, the greater the amount of erosion of the stream's bed. The heavier, coarser-grained sediment strikes the stream bed more frequently and with more force than the smaller particles, resulting in an increased rate of erosion. A common management strategy to control erosion is to maintain vegetative cover in fields along the banks of streams and around lakes to maintain stability of soils. As you can see on this image, river banks, especially on the other side from our perspectives, is protected by vegetation. Meanwhile, on our side you can see that it's less protected, and therefore river stream causes a small level of erosion across its banks. Proximity tool. So proximity tool can be divided into two categories depending on the type of input the tool accepts: features or rasters. The feature-based tools vary in the types of output they produce. For example, the buffer tool output polygons features which can then be used input to overlay, or spatial selection tools such as select by layer by location. The raster-based Euclidean distance tools measure distances from the center of source cell to the center of the destination cell. The raster-based cost distance tools accumulate the cost of each cell traversed between sources and destinations. So in order to create and to derive streams for our study area from them, we should create a mosaic for our mosaic of flow direction for our study area. So if you just deleted your flow direction or didn't save it, the mosaic, don't worry, we will repeat the same steps again. So I'm again just dropping my digital elevation models to my model maker, and I will use again fill tool for to just smooth my study area digital elevation models in order to create flow direction. So let's choose one by one. So this is 171. You can save it in your folder. So and name it. Do not, if you're saving in a separate folder, do not forget just to write the extension. .tif. So when we will finish fill operator, we will use again flow direction tool. This again from hydrology toolset. Just drop this function 5 times, and we will connect it with this field image, flow direction 1.tif. So this one. So we should create flow direction initially for the first for each image separately. Otherwise ArcGIS might find an error. So you might think that it would be easier just create a first mosaic and then just derive from the mosaic field mosaic dataset flow direction, but ArcGIS doesn't often finds mistake, error, or just hardly process and execute data that is mosaiced. So it is better to work with separate field images rather than just trying to calculate flow direction for the mosaiced image. And the next thing is this mosaicing. So go to data management tools, raster, raster processing, and raster dataset, and mosaic to new raster. So we will now mosaic this flow direction image. 3, 4, 6. So just a minute. Yeah, that's correct actually. It's number 5, not. So yes, number 5. Output location, flow direction, mosaic.tif. Oh, sorry, I should find the folder. And flow direction mosaic.tif with extension raster dataset name. It's unsigned 8-bit. Number of bands 1. It's a monospectral band, don't forget. So number of bands 8 bands. Spatial reference system will not change it so far. So click OK. So I will create first field, then flow direction, and then mosaic them. So at first validate your model and then run. So it's running step by step. So my model is completed now. I can edit. So it's my flow direction, and also we should add now flow accumulation. So it's my flow accumulation, remember, and which I derived from flow direction. And I need to extract values which can be considered as streams, pixel values. So if you will zoom to closer to the flow accumulation, you might see that certain areas, certain pixels have high values. See, white color, so they accumulate water and deposition. So I need to extract these values. In order to do this, at first I should understand which values I need to extract. So I will just go to classify and reduce the number of classes into 2 and click OK. So see, it automatically starts to divide. Let's see. So this is from black is from 1 to million and above million. So these are the biggest major streams, but I think that these values are too large. Mostly you know that experts suggest to take into account as pixel streams these values starting from 8. So above 8 and start more than 8. So see that this now I have much higher amount of streams. So I can also raise it until 10,000 because I don't need all streams. I don't need small streams, only the major ones. So now I want to extract them to only values starting 10,000. So I choose flow accumulation more than 10,000. So okay, so it's extracting only pixel values that have higher than 10,000. So I don't need this one anymore. So I have these streams, pixel streams, but the process is not over. I need to go to hydrology and go to the stream order. I need this file function stream order, and as input stream raster I will choose this one which I created, and as flow direction tool raster this one, flow direction, which I just derived. So as a method of stream, this one is strachler, is the most famous and widely used. So again, I can choose this streams. So it will be in raster format. And click OK. So my streams in raster format are ready. See, so these are the major streams. So this is the first order stream, second order, and third order stream. So the next step will be to just calculate Euclidean distance for the study area for each stream. So when we just derived streams in raster format using flow direction and flow accumulation, add your study area to the data frame and your streams as well. By the way, do not forget to reproject your streams if it's not in your in UTM format. If it's in projected coordinate system, go to just export data and use this data frame properties. For instance, I changed my data frame properties coordinate system into UTM, my zone. So if you just want to convert it into UTM, go to export data, choose this here data frame properties, and just save it. So I saved in UTM format. And now it's time to calculate Euclidean distance only for our my study area. So go to Spatial Analysis Tools, open Distance. Here is the Euclidean distance tool. So I will choose input raster UTM format. So maximum distance, let's say 300 meters. You can put more, but I think that it's not necessary because more than 300 meters is way far from the river bank, and such kind of areas are not prone to stream bank erosion. So output cell size is 30 meters. So it's our pixel resolution. So output direction raster, you can also choose here just this flow direction. So well, it's optional, you cannot choose, just click it here. So distance method is planner. So by the way, do not forget to save it. Euclidean distance streams.tif, save it. And before just clicking OK, don't forget, go to the environment. So here is the processing extent. So we need to choose our study area, our shapefile here. So this will be our processing extent. And also go to raster analysis, see, and as a mask choose again study area. So as a both as a mask and processing extent, we will use our study area. So otherwise it will calculate for all streams beside our study area and even for empty spaces. So we're just putting our extent. So this is our extent, this is our mask, and this is our extent. So if you put both mask and extend, it will calculate for streams only within the study area, within this shapefile. So click OK and let's wait. So my Euclidean distance is executed. See that I just created this Euclidean distance only for my study area. So these areas are not calculated, and the last step is just to reclassify. See, it's in this continuous format. So now we have here so far four classes. Probably you might have more. I just want to change it into 5, for instance, and go to classify, and so from 0 to 50 will be my first class, from 50 to 100, from 100 to 100, 200, from 200 to 250, and from 250 until 300. So this is my classes. See that we can zoom, so these are the closest areas and these are the most far areas from the streams. And now I can go to reclassify it. Reclassify Euclidean distance. So I have 4 classes. Now I should all reclassify from here, 5 classes, manual. So 100, so the first one is 50, 100, 150, 200 and 300. So 5 classes. No data is no data. So save it in your folder with TIF format. Click OK. So my reclassification is ready, and now it's time to add additional add field classes. Do not forget to always try to write classes. It will be easy for you during the last step, during the HEP and weighted overlay. So go to data, edit featuring, start editing. So I will write from 0 to 50 meters, from 50 meters to 100 meters, from 100 to 150 meters, so 100 to 200 meters, 200 meters. We can choose 0 to 50, 50, 100, 100 to 200, 200 to, so I created honestly, yes, from 200 to 300. So if you want, you can choose another classes, another distance. This is my own classification, which I will use during the weighted overlay. So my classes are ready, just to make it visually presentable, understandable. I will go to the symbology, unique values, classes. Okay, now it's easier to understand which color represents which distance. So this is my stream proximity map for my study area, which is now finished. Soil. What is soil? Soil is a mixture of organic matter, minerals, gases, liquids, and organisms that together support life. Components of soil. Soil in 45% is comprised from inorganic mineral matter, which is also called parent material, 25% from water, 25% from air, and only 5% from organic matter, which includes microorganisms and macroorganisms. Soil formation. Soil is a product of several factors. The influence of climate, relief, which includes elevation, orientation, and slope of terrain, organisms, and the soil's parent materials, original minerals, interacting over time. How is soil made? Soil made during the process which is called weathering. So on this image you can see that soil is made mostly from parent material, solid minerals, and during the process which is called mechanical weathering, which includes precipitation such as rain, hail and ice, and also wind and heat and cold, solid soil parent material starts to break down into fine particles. And during the spontaneous weathering, which also includes wind and other types of climate weathering indicators, and also during the processes called interacting with chemical weathering, which involves acids and moisture, it starts to proliferate into different spatial locations and starts to form minerals and nutrients, oxides of iron and alumina, silica, silt, and sand and the quartz. Earth's body of soil, called the pedosphere, has 4 important functions. As a medium for plant growth, as a means of water storage, supply and purification, as a modifier of Earth's atmosphere, and as a habitat for organisms. Living organisms in soil. 1 gram of soil has over 50,000 protozoa as well as bacteria, algae, fungi, earthworms, and nematodes. So on this image you can see the rich biodiversity of soil. So these are mostly microorganisms, and this is a macroorganism which is called soil earthworm. So these are bacteria, very small algae and fungi and nematodes, which is essential for fertile and healthy soil. Soil biodiversity in numbers. So we can see here that different soil flora and fauna, which includes algae, protozoas, nematoda, insects, bacteria, fungi, and mammals, live in a different deepness of soil. So on the top you can mostly live microorganisms, algae and fungi, and also bacteria and protozoa. Meanwhile, more larger organisms, macroorganisms, live in an area which is close to 60 centimeters, as well as insects and worms and mollusks. So different types of organisms invade different layers of soil. Soil profile. So soil consists of different profile, which has its own names. So the top soil is called O horizon, this one, which consists from leaf litter and organic material. This O horizon is very fertile soil and contains very rich in nutrients and minerals layer of soil. The second layer called A horizon, this one, and contains from plough zone rich in organic matter. So these two top layers, O horizon and A horizon, is vital for healthy soil where the vegetation can grow. The third layer is called B horizon, zone of accumulation. This horizon is not very rich in minerals and nutrients as well as microorganisms and macroorganisms and cannot be named as a fertile soil. The third is called C horizon, weathering soil, little organic material or life, so almost no life and no fertility as well as no plant growth occurs in this C horizon, as well as an R horizon, which is called unweathered parent material, this one. Soil parent material. So there are 4 types of soil parent material, which discerns only in size. The first one is called gravel, the largest soil parent material, as you can see on this image. The second largest soil parent material is sand, which is several times smaller than gravel. The third type of parent material is silt, which is way more smaller than sand. See on this image. And the third type of parent material is clay, and it's even smaller than silt. Soil texture. So you can see that different types of parent material, gravel, sand, silt and clay, also divide into several groups. For instance, gravel is divided into coarse gravel, medium gravel and fine gravel, and each one differs in size. For instance, fine gravel is close to coarse sand, as you can see here. So both of them have almost the same size. Meanwhile, fine sand in size is close to coarse silt, as you may see here. Meanwhile, clay doesn't have any categories because it is so small, so it's impossible to divide it into categories. Soil classification. Soil classification, which is also called soil taxonomy, deals with the systematic categorization of soils based on distinguishing characteristics as well as criteria that dictate choices in use. The grouping of soil are based on chemical, physical and biological properties and world reference base for soil resources. Soil pyramid. So this is the pyramid which is the basic and fundamental soil classification, and it divides in general all soil types into 12 categories of soil according to the percentage of existence of different parent material within this soil: clay, silt and sand, which are the basic parent materials. So for instance, if a soil contains from 60 to 100% of clay and from 90 to 60% of sand, as well as from 40 to 10% of silt, it is called clay type of soil. Meanwhile, if the most famous and widely proliferated type of soil is loam, it consists from 80 to 50% of sand, from 60 to 40% of clay, and from 30 to 50% of silt. So composition of 3 parent materials in loam almost equal. Meanwhile, if the percentage of sand is slightly above comparing to other parent materials, it is called sandy loam. Some types of soil according to World Reference Base. So these are the names of soils which are categorized according to their physical, chemical, and biological properties, as well as the percentage of different soil particles within them. So these are the histosoils, which has a unique feature, thick organic layers. Technosoils, containing significant amounts of artifacts. Cryosoils, permafrost affected. Solonchak, high concentration of soluble soils, which is widespread in Central Asia. Undersoils with allophanes or AI humus complexes, etc. So there are different types of classification of soils. The most widely and basic classification was shown in soil pyramid on the previous slide. This is the classification according to WRB. Also, there are different types of soil classifications which differ in number of classes. Soil ecosystem services. Soils deliver ecosystem services that enable life on Earth. So, soil is vital when it comes to carbon sequestration, because when plants and trees capture carbon, they store it in their roots, which are also located in soil. So soils capture carbon and store them. Water purification and soil contaminant reduction. Climate regulation. Nutrient cycling. Soil is essential also for habitat for organisms, because 25% of biodiversity, both for including flora and fauna, is live in soil. Flood regulation. Also source for pharmaceuticals and genetic resources. Also foundation for human infrastructure. Also, soil provides us with construction materials and stores cultural heritage, as well as provision of food, fiber, and fuel. So the life on Earth wouldn't be possible without soil. Soil degradation. Soil degradation is a decline in soil condition caused by its improper use or poor management, usually for agricultural, industrial, or urban purposes. It is a serious environmental problem. Soils are a fundamental natural resource and are the basis for all terrestrial life. Avoiding soil degradation is crucial to our well-being. Types of soil degradation. Soil salinization, loss of organic matter and organic minerals, wind erosion, water erosion, and soil pollution. So this is the global FAO soil data, which was created by Food and Agriculture Organization, which belongs to United Nations. And this data was created using a tremendous amount of field data gathered from all countries around the world. But do remember that this soil taxonomy and categorization is still raw, because it needs more data to analyze the soil compartments and soil physical and chemical properties for each study area. In case if you don't have any precise soil data for your local study area, it is better to use this FAO soil data. Otherwise, please, I foster you to use your own field measurements. So in order to create our soil map, we need to download file soil data of the world. So in case you have your own soil data for your study area, it is good. I encourage you to use your own soil file because it is more precise. For instance, you might get it from the national department or from other type of source information or etc. The soil data, which was soil map, which was created for specific study area using field data, is always more precise than global soil data. So anyway, in case you don't have, do not worry, we can use this file soil map shapefile. So click here and you will see that there's a global soil map which was created by Food and Agricultural Organization experts. It is raw comparing to, because it's global, but anyway it contains useful information which we can use. So if you will just type digital soil map of the world, you will see that there is a image which shows the digital soil map of the world, which contains dozens of soil types, and we need this ESRA shapefile format. You can click download. So I already downloaded it, and go to this folder which you downloaded and extract information. So you will see this multiple type of different information, and we need to add this shapefile, the DSMW, to our ArcMap file, ArcMap, and so it looks like this. So see, it contains multiple polygons for which contain different type of soil information, and we need also to add our study area, which we need to extract. By the way, do remember that initially this DCMW doesn't have a coordinate reference system, so you should give a VGS84 coordinate reference system for this global dataset. In case you don't know how to do it, just go to data management tools, projections and transformations, and define projection. For instance, I choose DCM and see that it shows my initial coordinate system, but no, not initial, the coordinate system which I gave, but initially it doesn't have any coordinate reference system. So please give VGS84 in the world, in geography coordinate reference system, and also add your you can also give another coordinate reference system. For instance, projected by initially I prefer geographic, and then we will convert it into projected UTM format. So anyway, now we need to extract information. So go to analysis tools, extract and clip. So I choose input feature this global soil data, and as a clip feature my study area, and I need to choose location. So I will say soil study area, so it will be in shapefile format. Okay, so see that it extracted the information which I need. So we can go to attribute table. So it contains multiple attributes. So it's file soil types as numbered, country, which is mostly present, and other types of data. We also will add another information from the Excel table. So and now we need to it's so far in coordinate reference system VGS84. Remember, we need to work with UTM, so I can delete this one and change this data frame coordinate reference system again to my study area reference system. So its outlook slightly changed, and I will again go to data, export data. Sorry, this is a shapefile format, so I need to go to data management tools, projections and transformations, and here I choose project, not define projection, because define projection only works when your dataset doesn't have any coordinate reference system, but my dataset does have. So its initial is VGS84, and I need to change it to this one for my study area. Go to layers and that system, and please do remember to choose soil study area UTM. Okay, that didn't add, so I can delete this one. So it's both in UTM format. See, it's in UTM format. So when we cut our study area from a digital soil map of the world, so it is time to research our attribute table. So we can see here that there are multiple attributes. For instance, soil number, foul soil, dominant soil, and the other attributes which are not necessary. And these attributes actually doesn't give us any relevant information whether which soil type is more prone to erosion compared to the other one. But when we open this folder which we downloaded, so there are multiple Excel tables here, you can see, and these Excel tables contain very important information when it comes to soil texture properties. So at first, let's open this generalized SU info Excel file. So we can see here there are dozens of attributes such as sand, topsoil percentage, silt topsoil percentage, clay topsoil percentage, etc. And this is soil unit symbol as well, which matched with our dominant soil type, as you can see here. And we need to add this important information to our this shapefile attribute table. But when we just look carefully, we can see that these dominant soil types are some in capital letters, or others are in just ordinary letters. Meanwhile here, for instance, if we will search GA, just a minute. So see that there is one also soil type which is also named GA, but this one is in capital letter and the other one is in ordinary letters. The same thing is with XK. So let's find XK. This is XK, also in capital. So we need to change first from capital to ordinary letters. Let's change it. GA, ordinary G. And the third dominant soil type is I, so I think it's the same as here without any change. So this one. So please find your soil types here and change, so make corrections so they would perfectly match to this writing, and save your changes. And now we are ready to convert Excel file. So go to conversion to Excel to table. We can convert Excel file into a table here, attribute table. So it created the table, just table without any spatial data, just attribute table. and we need to connect this attribute table to this soil SAUTM shapefile attribute table. So we will go to joins and relates, join, and we will just choose the field in the slide that contains the join. The join will be based on, so we will join dominant soil type, choose the table to join to this layer, or load the table from disk. So we will extract information from this table which we created according to dominant soil type, and the same information which contains the same data, the same table, is soil unit symbol. We can again just check soil unit symbol. Yes, see, soil unit symbol. So these are the same, these attributes contain the same information. Soil map unit, keep all records, join and validates. Okay, and now we can check again the attribute table. So we can see here that dominant soil type and soil unit symbol are the same. See, the same, but it contains also information vital for us when we need to just understand which soil type is more prone to erosion comparing to the other soil type. So before converting into raster format our shapefile, let us again open our attribute table and understand which soil type is more prone to erosion comparing to other soil types. So these are three soil types, dominant soil types, and they contain this kind of information. So we need percent of sand soil in topsoil, percent of sand in subsoil, salt, clay, and etc. So these are the major attributes that we need. So first let's go to sand soil and arrange according to descending. So we see that this soil unit symbol contains the highest value of sand in topsoil, almost 60%. Meanwhile, XK contains the moderate level and GA the lowest level. The same concerns the subsoil percentage, 56, and the second one. But this GA contains a high number of sand in subsoil. Meanwhile, XK contains the lowest number. The same concerns. Let's go look to silt in topsoil. So we see that in silt, in higher percentage in XK and in lower percentage in GA, and the smallest percentage in I. The same in subsoil comparing. So XK contains very high amount of silt in subsoil. So and clay, so it contains the largest percent again in I. So the moderate percent in XK and slightly above, and the highest percent in GA. In terms of topsoil percentage, so GA contains highest percentage, moderate, and this one is the lowest. So if we just if we will value the proclivity to soil erosion according to these 6 attributes, I can say that this one is has the highest proclivity to erosion comparing to the others. But comparing this is hard to mention, because percent of sand in subsoil is very important, because sand is more prone to water erosion, more prone to detachment by water and wind comparing to silt and clay. They have the slightly smaller amount of sand in topsoil, also in subsoil as well, slower amount. Silt and clay are less prone to erosion because they are in smaller. They have a smaller amount. They have smaller size. Therefore, they are less prone to detachment by water. So the higher the percent of silt is better. So this XK contains a higher percentage. This one is second place. This one is third place in topsoil, and the same is concerned the subsoil. So this is silt in a very high amount. But clay, for instance, clay is even smaller than silt, so it's less prone to erosion even silt, while silt is less prone to detachment compared to sand. So GA contains the highest level of both topsoil and subsoil clay, and this one are the second and third places. So I is the highest one, I value, XK is the moderate proneness to erosion, and GA is the low prone to erosion. So let's create a table. So proclivity, let's say, and I will write here text. Okay, so created proclivity, and let's go and start editing because this first one is I will write high. So this one is XK. I just mentioned it's moderate, right? Moderate proclivity, and this one is low proclivity. So and let's save and stop editing. So our attribute is added. So according to this attribute, we will make a conversion from to raster. Go to conversion tools, to raster, and choose polygon to raster. Soil SA. So the last one, right? Should find here proclivity. Yes, this one. Proclivity, cell size, don't forget to write 30 meters. So priority field no, cell assignment type cell center. So soil texture, right? Let's write. Okay. Don't forget to write extension. So these are my final soil texture and soil types map. So this area, now let's change the color. So this, let's change it to red. Low is green, and this one is moderate, is, this is yellow. So this is high prone to erosion, this is low, and this is moderate prone to erosion. Precipitation. Precipitation and soil. Soil and water being splashed by the impact of a single raindrop. Rainfall and the surface runoff, which may result from rainfall, produces four main types of soil erosion: splash erosion, sheet erosion, rill erosion, and gully erosion. Splash erosion is generally seen as the first and least severe stage in the soil erosion process, which is followed by sheet erosion, then rill erosion, and finally gully erosion, the most severe type of erosion of four. In splash erosion, the impact of a falling raindrop creates a small crater in the soil, ejecting soil particles. As you may see on this image, a small tip covered in rills and gullies due to erosion process caused by rainfall. This is a type of hill which is located in Rumu, Estonia. The distance these soil particles travel can be as much as 0.6 meters vertically and 0.5 meters horizontally on a level ground. If the soil is saturated or if the rainfall rate is greater than the rate at which water can infiltrate into the soil, surface runoff occurs. If the runoff has sufficient flow energy, it will transport loosened soil particles, sediment, down the slope. As you may see here on the image, the surface runoff creates soil erosion, and due to intensive irrigation practices, and soil is so saturated that it cannot infiltrate water, and water due to slope, especially on areas prone with high steep slopes, starts to cause water erosion. Sheet erosion is the transport of loosened soil particles by overland flow. So this is a type of sheet erosion. So mean annual precipitation, British Columbia. So precipitation can be displayed and represented in GIS platforms, because precipitation also varies spatially from region to region. So here on this image you can see the precipitation for southern British Columbia, mean annual precipitation, and in some areas there is a very high level of precipitation, in other areas very low level of precipitation in millimeters. So how this was calculated, as Spatial represented. So basically hydrologists and meteorologists gather field information from multiple locations for each month, and finally they sum up all months precipitations for a certain year, and thus creating annual precipitation. Precipitation influence on erosion. So how precipitation might cause erosion? So which factors of rainfall and snow also, and other types of precipitation might cause erosion process? So this depends on frequency of precipitation, how often do your study area and experience precipitation and rainfall, and etc. For instance, in some areas almost every week, twice a week. Meanwhile, in other regions, once in 3-4 months, mostly in arid and semi-arid regions. Also, it depends on intensity. So intensity of each rainy day, for instance. In certain days, intensity of rainfall can be very slow, but the duration may be higher. For instance, in some regions, for instance in my region, the precipitation might be with low intensity, but continue 2 days. But in other regions, for instance, especially in certain seasons, in summer, for instance, the intensity of precipitation can be tremendously high, but duration is only 1 or 2 hours. So, and the size of the area, also on which areas precipitation raindrops fall. So this type of precipitation data, which gathered by meteorologists and climatologists, also So you can see that precipitation varies from month to month. So this is field data, all valid and verified precipitation data gathered by field experiments. So they show always precipitation always linked to longitude and latitude. This is the area of British Vancouver. Also see that average elevation of study, and this is our monthly precipitation, and these are other types of data which meteorologists also always gather. So this is for year 2010. So but there is also a modeled precipitation which was created by University of East Anglia Climate Research Unit. So you can see on this image this is a global data for global precipitation in MCDA format, which you can find through this link, and we will download also this global precipitation data and afterwards extract for our study area. But this is just estimation of global precipitation. If you have your own precipitation data, it is always more accurate, and it is better to use for your analysis. So in order to download Climate Research Unit precipitation data, so Google just Climate Research Unit precipitation data, and you will see this link, high resolution gridded datasets, Climate Research Unit. So go here and you will see this kind of page. So we need this latest one, CRUTC 4.05, the current version using a revised interpolation function and superseding this version, Grimmett time series dataset, released on March 2021 and covers period for more than 1 century. So available at SEDA, but I prefer to download from a local copy, so I will just write local or click local copy. So you can read first about basic information. This is a metadata for this gridded dataset, and then go to this link, main grid dataset, and you will see the data variables. So this is the potential evapotranspiration, this is temperature and other climatic variables. We need only precipitation, so I will click precipitation, and there is a list of data of precipitation modeled for each decade, mostly. See that from 61 to 70, etc. So I will download the latest one from 2011 to 2020. We don't need this kind of data. We need pre.ncgs, so this one. So now we can download. Just click save. So it's approximately more than 80 megabytes. So when we download it, let's extract. So I extracted, and inside you will see this kind of pre.dat. It's in NetCDF format, and the next video we will open this file and extract some information for us. So when we downloaded our NetCDF file, it is time to look at it. So go to multi-dimensional tools, NetCDF raster. So this is my NetCDF file. So X is longitude, Y is latitude, so precipitation, and band dimension is time. Okay. So this is our global precipitation data. So it's multispectral, and each band shows the months. So we have here so we download the data for 10 years approximately. So we have 120, approximately 120 months. So each band represents the information for each month of 10 years, for the 10 years. So, but we need only the small area of data. So for our study area, and let's download, just add study area in order to look at it. So this is my study area, and so we need to extract only small this area, this extent. So I will zoom to my study area. So this is enough, I think. And right click with right button of the mouse, data frame properties. No, sorry. Go to the precipitation and go to data, export data, and here we will choose extent. Say extent, so and in so then we will change the coordinate system. So go to here, let's save it. So okay, precipitation, study area. Yes. So I can delete this one. No, I can close this one and delete it. So I extracted information for my study area, and but you can see that projected coordinate system is different, as well as cell size. So but initially I will convert this pixels into points, and then create interpolation. So go to conversion tools, from raster to point. So precipitation SA, and no, sorry. Initially I need to just sum up all months for my study area for 10 years in order to find the annual precipitation, not monthly. So I should go to spatial analysis tools, local, and here's cell statistics. I will choose my precipitation. So here is sum. Let's save it. Some precipitation TIFF format. So this is a sum of my precipitation for study area for 10 years. You can choose 1 year, 2 years, 3 years. I prefer 10 years because it shows more precise information, because precipitation also might change for study area from year to year, and this is long year precipitation, long time period precipitation, and this gives us more precise information in terms of rainfall. So, and the next is now I need to convert using conversion tools from raster to point. Precipitation study area, and yes, this is value, field optional precipitation value. So some point, and it's in shapefile format. It will be points. See, now I created point dataset where each point contains information. sorry, I accidentally converted this precipitation to points, but I now converted this raster sum of precipitation into points. Now my points are ready, and it contains information. Each point contains information for this large area in terms of precipitation. So precipitation information for 10 years. Now in the next video I will create interpolation using Kriging method for 30 meter pixel resolution. So before creating interpolation, let's convert our sum points into UTM format. So data management tools, projections and transformations. So I will use project tool, sum points. Now it's in VGS format. I will use this my study area UTM zone. Okay, so I can just delete it now. So it's in UTM zone now. Sum points, properties. Again, I will change my data frame coordinate reference system to UTM. You can see that the shape is changed, but anyway, and now we're ready to create interpolation. Kriging, sum points, grid code. Now I will name it kriging.tif. So cell size, if you will not change the coordinate system of your sum point, cell size will be in degrees. So now when we changed into projected coordinate reference system, cell size in meters, I need 30 meter, but it will take time now I will prefer to leave these options: semi-variogram properties, ordinary, semi-variogram model, spherical. You can make more research if you're familiar with data science and statistics and mathematics, but I will not just immerse you into the theory. I will just prefer to leave this optional way. Output cell size 30 meters will take some time to compute. Therefore, while processing, I will pause the video. So, start it. So my interpolation is finished now. I can close this dot points, and so see that it created the interpolation for precipitation data using Kriging method with 30 meter pixel resolution and VGS 42 zone. And I need just now to extract my study area. I go to Spatial Analysis Tools, Extraction, Extract by Mask. So this is my Kriging and this is my study area, UTM. So precipitation, UTM, study area .tif. Okay. So now, so see, this is precipitation for my study area. I can go to symbology, classified. I can change the outlook. So these areas have in general during the last 10 years higher level of precipitation. These are the smallest. These are also moderate level of precipitation. And the last thing, I need to use reclassify tool, precipitation. So value, again I will use 5 classes. Natural breaks, I change to 5. Manual. So actually I can leave natural breaks. So this is despite the fact that the difference is not significant, I will leave these 5 classes and precipitation reclass.tif. Okay, and click OK. So this is my precipitation in discrete format. I just need to again add field classes text 5 4,383 millimeters, 4,836 millimeters. So 4,836, 5,113, 500, 1,013 until 500. So approximately difference between classes, I think it's close to 200 millimeters. So it's for 10 years it's not significant amount, but anyway, areas which have a higher level of precipitation during the last 10 years are more prone to erosion comparing to those who had a small amount of precipitation. So save edit, stop editing, can go to properties, unique classes. So see this now I can see that this area is higher level of precipitation. So that's it, my precipitation data is ready. So now it is time to start HGP analysis. First, open your Excel file, empty Excel file, name it HGP comparison, and we will work with different multiple lists here. So my work is completed, and I will explain to you how I conducted my HGP analysis. So here we have two columns. First column is just different layers, thematic layers, which I used, which I created during my previous videos. It's a land use, land cover, slope, curvature, topographic wetness index, stream proximity, and soil type. And this on this second column also these thematic layers, but they differ in a row. For instance, in this row I compare land cover with slope, and trying to understand which thematic layer is more important and has a higher impact to proclivity to soil erosion, by just ranking and by just numbering, assigning certain numbers for on this row. For instance, in comparing land use and land cover thematic layer with slope, where one represents that they both equal, so none of these thematic layers outperform others thematic layer. Meanwhile, this edge values 9 represent that this or other thematic layer is more important comparing to the former one. So in this case, I just I assigned 5 to slope, comparing with land cover class, because I am sure that slope is vital when it comes to soil erosion. First of all, water erosion. Comparing land use, land cover with curvature, I also prefer to think that curvature assigns more values, higher has higher impact comparing to land use land cover, but less than slope. Here I assign 3. The same concerns topographic wetness index. I think that it's more important comparing to land use class. Meanwhile, comparing with precipitation thematic layer, I think that land use land cover is more important, because in my study area, precipitation, as you might just noticed in previous videos, doesn't significantly vary throughout space, but if you're working with large spatial data, I think that precipitation and land use and land cover might differ, or even precipitation might outperform land use land cover if precipitation significantly differs from place to place. But in my study area, I think that land use and land cover is more important, because I have different land cover classes, which has a totally different proclivity to erosion. So soil type and land use cover, I think that they are both equal, so I assigned 1. Land use and land cover, I just might zoom. So land use and land cover, in comparing with stream proximity, I think that land use and land cover is more important, so I assigned not just slightly important, but significantly more important. That's why I assigned it number 5, because stream proximity covers much less area than land use land cover, and also I derived the larger streams. That's why my land use stream proximity covers approximately 20-25% of the total my study area. Meanwhile, land use land cover covers 100%. So that's why stream proximity, why we need this thematic layer, because it might cause riverbank erosion. Meanwhile, this is only one type of erosion. We're working with different types of erosion, gully erosion, etc., real erosion, etc. So only river banks might be prone to stream erosion. Therefore, we need stream proximity. But in comparing with land use land cover, I think that it's the former one is more important, because it covers the whole study area. So in comparing with slope and curvature, I think that curvature slope is more slightly important than curvature. But anyway, in all types models, trying to model water erosion, slope will always will have a dominant position comparing to other factors. Even in just working, for instance, in Russell model, and other types, SWOT model, etc., other types of model, slope is vital when it comes to understanding soil water erosion proclivity. And moreover, curvature is derived from digital elevation model as well as slope, but curvature is more complicated. So anyway, the same concerns topographic wetness index. Actually, topographic wetness index is related to slope, not only because they both were derived from digital elevation model, but also slope, as you remember, slope gradient is included in topographic wetness index formula. So stream proximity and slope, I definitely think that slope is way more important than stream proximity. Slope is the most important factor and thematic layer in our study. Soil type and slope is slightly important, as well as precipitation, not slightly, significantly, but I assigned 5. The curvature and topographic wetness index, I think that topographic wetness index again is more slightly important, because it shows the areas which capture where water and soil deposition accrues. So this is also a very important factor, slightly important than curvature. and it's more slightly complicated than curvature. Meanwhile, stream proximity and curvature is, I prefer curvature slightly, etc. So you may see here that I have 21 comparisons in general. So it depends on your number of layers you're going to use. In my case, I have 7 layers, and therefore, according to the formula, as you might remember, this formula, for instance, therefore here the number of things, in our case number of layers, and number of comparisons 21. So in case you also created 7 thematic layers, you also in general must have 21 comparisons. So I compared all layers, thematic layers, with each other without no exception. So my ranking is ready. So the next step is creating a reciprocal matrix according to these rankings. So just open new list in Excel, and again here, as was done in this example, in this file, Word file, as a template. So again, I just wrote down all my thematic layers, as well as to this vertical and horizontal columns, and now I starting to assign values to my cells. So when comparing LU and LU, it's 1. So see, in diagonal it's always 1, and in other cells I start to write down numbers in fractional format. So in case you just need to just use fractional format, it's better, I think, but you can also use ordinary format of values. So anyway, when comparing land use and land cover and slope, I assign it to slope 5. Remember, 5 here. That's 4. Therefore, I write here one denominator 5. Meanwhile, in this case, in comparing slope to LU, LC, I write 5 because I prefer slope of 5 times than LU, LC. So in this case, it seems to me that I prefer curvature 3 times to land use, land cover, as the same as topographic wetness index. We can compare, for instance, yes, this one is 3. So precipitation, I prefer LU, LC more than precipitation 3 times. Meanwhile, here in comparing precipitation with LU, LC, see, in this is one denominator 3, because precipitation, just roughly speaking, loses battle against LU, LC in this case. So I will explain in some kind of childish way. So here LU, LC and soil type is a draw, and LU, LC 5 times outperforms stream proximity. The same thing is here. For instance, stream proximity 1 denominator 5 comparing to LU, LC, because it lost the battle. So it lost the battle to all thematic layers. It's the least priority for me, stream proximity, despite that it's important, but it's might cause only riverbank erosion. Therefore, it loses all the battles except it takes draw with himself. So the same. So slope is almost won all battles. Curvature lost to slope, and topographic wetness index and soil type. So this is a reciprocal matrix. You should fill according to this assigning values, and then you should sum all the columns for each thematic layer. See, these numbers in order to get this number. So create reciprocal matrix and sum columns. So when we created reciprocal matrix and also calculated sum of columns, again create a new list, and again we should write all names of thematic layers for horizontal and vertical. And again just copy all these values except sums, all these reciprocal matrix to this place, to new matrix. But in this case we will also divide all these values of reciprocal matrix into the sum of its columns. For instance, in this column I divide all values into the sum of LULC. So LULC, I divide all its values into its sum, and I got very low values, and in general you should have in sum 1. So if you will sum all these values, you should get 1. So again, glance back to our example. So so when we create reciprocal matrix, we sum all its columns, see, sum, and then we divide all its values into sum of its columns. So when we divide 1 into 21 denominator 5, we get 5 denominator 21, vice versa. So in this case, when we divide 3 into 21 5, we get 15 denominator 21, etc. So divide all values of reciprocal matrix into the sum of its columns, and in general in sum you should get 1 for each column. See, we can again check here. For instance, in here I have 0.0 denominator 5, so it's 0.2, right? 1 denominator 5, and I divide it into 2.41 to this value, just to this value, sorry. So, and I got these values. Again, I divided all of these values into 2.41, and in sum I should get 1. So all columns in sum must be 1, otherwise you have some mistake. So repeat these steps, and then we should sum now its rows, every record for each thematic layer. In here, if we sum with column, here we should sum its values, which depends to the same row, all these values, see, and so I here got these values when I summed my rows, but yes, here I again sum all the rows, values of the same row. Also, do not forget to divide to the number of to multiply, sorry, to 1 in denominator number of layers, in my case 7. So I just decided to divide into 7. See, I divided all these values to 7, and I got these values, this. So these are the just normalized principal eigenvector, and you can just use the percent tool here, this one. I can again show here. So see, it's the same thing, so it's easy to convert into percent. So this are my percent values for each thematic layer. So I can say that LULC I value 10%, slope I value the highest, 37%, more than 1/3. So curvature 10%, topographic wetness index 20%, precipitation 8%, soil type 11%, stream proximity 3%. Again, you should not repeat the same values for your thematic layers as I did. You can assign different values according to your perspective, according to your research, and according to your study area. I think that these values are appropriate according to my experience. Probably I'm wrong. Anyway, according to your assignments and the values will depend the final result of your soil erosion analysis. So the next step is to compute principal eigenvalue. So these are my sum of each row divided into 7. So these are my principal eigenvector values. And the next step is compute principal eigenvalue. If you remember from the example, so these are my numbers here, which I then converted into percents, and then I just multiply it to sum of the column, to these values, just multiply to sum of each column, and eventually sum all values to each other. So these are all my values, and I just multiply to the sum, to sum of its columns. See, it's in LULC it's 1353, so 1353, and slope is 2.41, etc. So I just multiplied my these values to sum of the columns, and I eventually summed all these values into one, and this is my principal eigenvalue. It's my principal eigenvalue now. The next step is to compute consistency index and ratio in order to understand whether our rankings are consistent. So again, in order to do this, let's glance back to our example. So when we rank it, or when we compared all our things with each other, remember, first we prefer banana to apple, thus we say that banana has greater value than apple. Next we prefer apple to cherry, then we prefer apple greater than cherry, so we write this. So according to these assumptions, we can say that we prefer banana more than cherry. This will be consistent answer. Must be preferable than cherry. The logic of preference called transitive property. Your answers in the last comparison is transitive. So on the contrary, if you prefer cherry to banana, then its answer is inconsistent. This consistency is closely related to the transitive property. So anyways, this is my consistency index, how it's derived. So I just my value eigenvalue minus number of thematic layers and divide it into number of thematic layers minus 1. So this is consistency index. So this is my eigenvalue, remember from the previous 7.91. And minus number of thematic layers divided into number of thematic layers minus 1. So this is my consistency index, and so this is my previous example eigenvalue. Here they have 3 examples, therefore they subtract a number of 3 from thematic from eigenvalue and divide into 2. And in order to understand consistency ratio, we should divide consistency index into random consistency index, which was derived during the computational modeling. So this is a table of random consistency index for 10 things. I have 7, so this is my number. and I should divide it into this my consistency index. So see that I divide consistency index into this value 1.32, and I got without percentage anyway this value. Actually I got 0.11, and I converted it into percents. I can change it to sorry. So this is my value 0.11, and I convert it into percent 11%. This shows that my ranking is not quite consistent, because consistency ratio must be smaller or equal to 10%. Mine is 11%. This might be because in some cases I rated topographic wetness index slightly above. I just assigned higher values to topographic wetness index than I should do, because in some cases when comparing slope and topographic wetness index, and also comparing slope with curvature, I gave the same values here for slope and curvature. Slope, I preferred 3 times slope and 3 times slope again, comparing to curvature and topographic wetness index. But you can see here that topographic wetness index 20%, which shows that in other cases I prefer topographic wetness index way more than curvature. See that I can see where is my topographic wetness index. See, they must be equal, but I assigned 3. This might be the reason why my consistency ratio index is 11%, but I think that I assume that this my ranking is sufficient, appropriate. I think that topographic wetness index is more important, but anyway you can assign the same values and your consistency index will be less than 10% definitely. But I'm not going to change this. I think that 1% is not very significant in order to condemn my HEP analysis. So 1% is appropriate. We're not just dealing with huge investments or business or just hazards assessment, etc. So 1% doesn't make a huge impact to the final result in our case. So this is the end of my HEP analysis. I will try to download this file, converting it to other format. Anyway, I think that you should do the same steps from the beginning in order to immerse yourself to the HEP analysis principle. So when we created all our thematic layers, so I just deleted all previous data frames and just added to the last data frame which I created, HEP soil erosion model. So this are all my thematic maps which I created during the course, and as well as study area shapefile. So now the last step is to use weighted overlay function to create this soil erosion model using HEP. So at first just check your coordinate system, and thematic layers, do they overlay with each other or not? So, and just add all your thematic layers. So, and open also our Excel file where we created where we calculated this percents. So I just changed from integer to float, adding just additional numbers after just comma, so in order to make it more precise. Now let's go to the spatial analysis tools, overlay and weighted overlay. So let's starting to add all our thematic layers one by one. So as an input field, always add this additional this attribute field which we added, classes. So this starting to add all thematic layers. So texture, again this one, topographic wetness index, reclass, and now we should start to assign weights in percents for each thematic layer. So this is my percents. First, land user land cover, it's 10%. So where is my land use and land cover? Yes, classification. I will assign 10%, so in general they should be 100%. So slope is 37%. So topographic wetness index is 20 and 4%. And this precipitation is 8%. The next is soil type. It's 11 and 3. And stream proximity, let's say it's 3%. So in general, so see that it doesn't just a moment, it doesn't create assign percents which have float numbers. See that topographic wetness index actually 20 and 4%, but I cannot write 20 and 4, so I can write 21 in general, right? So topographic wetness index, now I have 100% in general. So slope, and now it's time to assign scales for each class according to their influence to general soil erosion. So the smallest number, you can change evaluation scales here, that it can be either from 1 to 9, or you can change the scaling. So I would prefer from 1 to 9. It's more easy to work with. So from 1 to 10 degrees is 10, a 1 scale. From 10 to 17, let's say 2. From 17 to 25, I will assign 3. No, I can assign 4 here. From 25 to 33, 5. From 33 to 42, 7, and the highest slopes will have 9 scale. So precipitation, higher the precipitation, more proneness to proclivity to erosion. So the difference is not very big, as you might see here. It's precipitation for 10 years. So and to the last one I will assign 8. You can choose your own scaling and values. I do not impose my values, my vision. Just initially it is better to do a literature research and analyze what values and percents were assigned by other scientists and authors. So Euclidean distance, so this class will have 9 because it is close to riverbank and streams and very high prone to stream bank and erosion. So this will be 7, this will be 5, and this will be 3. So when choosing these no data values for all thematic layers, so no data values, leave it the same except this string proximity, no data as 1, because otherwise that other areas see that this is my stream proximity, right? So these white areas are have no data, and when calculating weighted overlay, ArcGIS will just do not calculate soil erosion for this white area. So therefore it is you should assign for no data as 1, so it will have the lowest, almost no importance. So soil texture, so this will be 9, low it will be 4 for instance, and moderate it will be 6. So topographic wetness index 1, 3, 5, 7, 9. So curvature, do remember that minus values are concave and they have very low influence to water erosion, because the water stream, water speed decelerates due to just convex shape, and positives have vice versa, accelerate water stream, while these are close to 0 are linear. So I will assign to these areas 5. So this will be 1, this will be 3, this will be let's say 7, and this will be 9. So classification, the last my thematic layer. So glaciers, when glaciers melt, they start to cause soil erosion, water erosion, deposition. Therefore I will assign, let's say 5. No, let's leave it 4. Water, so water is 0 because it's not prone to erosion. So range length, I will say 6, or let's say 7. Forests, let's say 4 as well, because they're protected by trees. Barren land has the highest proclivity to erosion. Urban are 4, rocks are 5. No, rocks are 3. No, let's say also 4 because they are mixed with soil. So urban, let's say 5. So this is it. I think I will just assign for topographic wetness index 20, but for Euclidean distance I will assign 4. This in general will be more fair, I guess. So this is it. You can save it, by the way. Save table. You can save it for as a text txt file, and then you can just again upload it again. So, and by the way, before just clicking OK, go to environments, processing extent set to study area UTM, and for raster mask, raster analysis, mask, study area UTM again. Okay, and now it's computing weighted overlay. So now it's ready. You can see that it has several classes. See, from low to high. I will change classes colors. I will say I will want to assign. So for instance, these areas are low, prone to erosion. These are high. I click OK, and now it's more clear. See, so these areas are very low, prone to erosion. These areas red are high, prone to erosion. And I want to reduce number of classes until 5. It will be easier to understand. So go to symbology, unique values 1, 2. So these classes will have very low. So just click, choose both classes using Control, pushing Control, and with right button of mouse, group values, and name it very low, and follow the same steps. So pressing Control, choose these classes, group value very high. So this will be high, low, moderate. So I will write here low, I will write here high, and this again will be group values moderate. Now it is more clear and easy to understand, I think. So these classes are, most of classes are moderately prone to erosion according to our estimation. In the next video, by the way, we will just calculate the areas. Most areas are low, prone to moderately prone to erosion, and some values are high, prone to erosion, and the values will change if you will just change this percents. For instance, if you will assign other percents, other ranks for just other classes. So the most important layers are topographic wetness index and slope. Class curvature, etc. So and now let's calculate the areas of classes. So now it's time to calculate the area of classes. Go to attribute table. So by the way, if your how to say, final file is not in projected coordinate reference system, please change it to projected, otherwise you will not be able to compute territory area. It's possible only in a projected coordinate system. If in case you forgot, just go to data, export data. So just change it. First change your data frame coordinate reference system into projected UTM. Choose data frame and 30 to 30 meters and just export it. So I'm going to this attribute table, go to add field, area. So I will choose float numbers. Do remember that in case you merged your classes in symbology, as I did in previous, so using this group function, right? This will change only here in representation, but this will not change in attribute table. It will not reduce the number of your classes. So keep this in mind. So go to, so we press right button of mouse and go to field calculator, count, multiply it into 900. So the number of pixels I'm multiplying into the total area of one pixel. It's 10,000 square, 900 square meters, and divided into 10,000. So 900 meters into 10,000. So this total area of my classes in hectares. Remember that you can divide it into 1 million. In this case, you will get the number area in square kilometers. I preferred hectares, and the total area of 1 hectare is 10,000 square meters. So this is total area of hectares. You can also change it into 1 million, right, in square kilometers. So see that these two areas, these two classes, which with a very low probability of water erosion, very low probability, is very small. It's less than 60 square kilometers. So this is low probability, right, or close to moderate. It's very high, to 961,000 square meters. This both have moderate probability, right, of water erosion, approximately 3,000 square meters, and these are high and very high, also small territory. You can also calculate percentage. Add one field, right? You can add again float. So percent. So first we should find out the total sum of the territory in square meters, right? It's 4,000. This value is 4,177 square kilometers, and we're going to calculate percent. I will delete this equation. So percent. So I will take the area. I will take the area and divide it into this value. I can just delete after 0. So okay. So this is the percentage, right? By the way, you can then multiply into 100, right? Because if you're going to calculate in percentage. So this is in percentage. 23%, 54%, 20%, less than 1%. It's almost close to 0. So this is your this is values of water erosion proclivity for this study area. So when we finished our work, now we can just print our maps or add them into our article or our dissertation. So we will create final legend of a map. Initially, please go to this empty space and click with right button of mouse and check that your layout is checked. This is my layout table. instruments which I will use during my map presentation. And now go to view and go to here layout view. See that it already showing. So in case if you have another layout, go to this change layout, and you can change you can choose any layout you want. For instance, I prefer with this 24 inches and 63 inches. See, the layout slightly changed. So in case you want to move just this window, you will use this pan tool. In case you want to move this map itself, you will use this tool. So if you're going to zoom in, zoom out window, use this zoom out, zoom in, or if you're going to zoom this map, see, it's slightly becoming bigger. Yes, so you will use this plus and minus zooms. So, and I changed my layout into landscape, but now I need to add a legend. Go to insert and legend. So I don't need the slope, I need only HEP, this one, this class. And I'm going, so okay, here in background I'm choosing 10% gray. Okay, ready. So I will move it to the north western side on the top right bottom. So everything seems to be okay except this. I don't need HTTP soil erosion and value, so I will go to, with the right button of my mouse, click on this legend and go to properties, and I will click here this items. It's showing, if you show it in general, go to items, and here is my layer name and legend. So I click double times, and I should remove the show layer name and show heading. Okay, okay. So see, it now it doesn't have this annoying layer name, just it has values. I can change also the name of instead of just putting legend, I can say susceptibility to water erosion. Now it's more clear what does these values represent and what does these colors represent. And I can also I want to add this geographic coordinates, longitude and latitude, to my data frame. So I go to my data frame name, go to properties, and go to grids. If you're in general, for instance, go to grids and create new grid. So I will choose this one, gratical, divides map by meridian and parallels. So I need this one. I don't need graticals and labels, I need only labels. So okay, okay, finished. See, it's it now exists, but it's in very it's almost invisible. So I want to change it. So I want to increase the font size. So I go to grids and graticals and double click with the left button now. See, it's a very small size. I'm going to increase it until 36, okay, and choose this one as well. And also my label orientation will on the left side and on the right side will be vertical. I think it's more convenient in this case, will look more attractive. So okay, see, now I have totally different map outlook. Susceptibility to water erosion. Now I have coordinates here, and you can also go to properties in case you want to see more these numbers. You can go to graticals again. If you want to decrease an interval, for instance, for x or for y, you can change it. For instance, I'm going to say that this will be 0 and this will be 5. This will be 0, this will be 5 again. So see, now I have too many labels. Probably I will leave it 1.5, 0, 0, 0.5. No. Probably I should leave it 0. Yes, okay. So now also we can add north arrow. I prefer this one. We can change the size of north arrow, and I will put here. If you're going to move this map, you can use this pan tool. And also I'm going to add what else? Title I can add. For instance, and you can say this your study area. You can write here your study area. You can increase the name outlook. No, it's too big. I will put 50. So now it's okay. So in case if you want going to add other functions, for instance scale bar or scale text, etc., you can add with this tool. So I think that just a legend word would be enough, because I already mentioned here what does this mean, what does this map mean. Anyway, you know how to just change now your legend outlook. And so my map I think it's ready. Now I can just save it, go to files and go to export map, and you can save your map in JPEG format. I will name it HEP. So I prefer, I suggest 300 dpi. It's high quality, so most of articles and most of journals accept it in JPEG format. So let's save it. So let's open. This is my JPEG file. So this is my final map, how it looks. You can see that everything is clear, and any viewer can understand which areas are prone to erosion. So I will pause the video here, and please repeat the same steps with the other maps as well. So all my maps now is ready already. So I added all my created maps for all my legends and for my layers. So this is HEP as I just represented. So this is a curvature, It is up to you which color you will choose to present. This is land use and land cover class of my study area. This is precipitation. It is always better to show precipitation with some color which represents water, etc. So the blue dark colors represent high precipitation and light blue colors represent low precipitation, and I wrote here in millimeters. So you up close to legend you can write the unit of measurement here in millimeters. So this is for last 10 years. So classification is unitless, curvature is also unitless. This is the slope of my study area in degrees. Soil texture also unitless, and stream proximity in meters as well. And this is topographic wetness index, also unitless. So this is it. And by the way, in case you can also add a base map as a front layer, as a background layer, if you have good internet. So for instance, I prefer this one, imagery. So it's adding to the background as a background layer. So it's downloading so far. I can probably close this one. Hope you have a good internet speed. So now it's downloaded. See that this is my study area outlined with black color. And also we can also just click to any layer, and you can slightly make it transparent, going to properties, display. Here is transparency. For instance, I put 40%, so it will be 40% transparent. See that also now it can be somehow matched with the background. Or for instance, slope 40%, or okay, 50% transparent. So see transparency, or better to choose final map, and let's make it transparent, 45%. And you can also increase brightness, for instance 150%. No, 20%. But it looks not very good, so I will remove it. Contrast probably is more appropriate to choose. So, and also you can again go to layout view and so go to, for instance, again, soil erosion, susceptibility. I can delete this legend and add again. So I don't need this one, all these layers. So see that looks different. I think this one is more, looks more visually presenting comparing to just ordinary maps. You can change also the color of your title, for instance, to this one. So and also export it using the same tool. So it looks more attractive if you're going to publish an article.